There is a moment in every firefight that has nothing to do with courage, nothing to do with training, nothing to do with the righteousness of your cause. It is the moment your weapon stops firing, not because it broke, not because it jammed, but because it ran out. The magazine went empty. And in that silence, history has been rewritten more times than any of us care to count. Welcome to the most comprehensive exploration of firearm magazines ever assembled. Not the flashy world of calibers and muzzle velocities. Not the glamorous debate over rifle platforms. No, this is the story of the box that feeds the beast. The container, the spring, the follower, the geometry of stacked brass that determines whether a weapon is a single-shot curiosity or a relentless engine of sustained fire. Before we classify a single magazine type, we need to understand something fundamental. A firearm, stripped of its feeding mechanism, is essentially a one-trick pony. Pull the trigger, it fires once. Then you must manually open the action, remove the spent casing, insert a fresh cartridge, close the action, and fire again. That entire cycle can take a trained shooter 3 to 5 seconds. In combat, 3 to 5 seconds is an eternity. The magazine changed that equation. It is, at its core, a container that holds multiple cartridges and presents them, one at a time, to the weapon's action for chambering. That sounds simple, deceptively simple, because the engineering challenge of reliably feeding metallic cartridges under the stress of recoil, dirt, cold, heat, and the sheer violence of automatic fire is one of the most demanding problems in mechanical design. Consider the forces involved. A standard AR-15 pattern rifle cycles at roughly 700 to 950 rounds per minute. That means the bolt carrier group is slamming forward, stripping a round from the magazine, and ramming it into the chamber roughly 12 to 16 times per second. Each time, the magazine spring must push the next round upward into the feed position with precisely the right amount of force. Too much, and you get a double feed. Too little, and you get a failure to feed. The margin for error is measured in fractions of a millimeter. And that is just one type of magazine in one type of weapon. Across the full spectrum of firearms, from pocket pistols to vehicle-mounted machine guns, the magazine takes on dozens of radically different forms. Tubes, boxes, drums, rotary spools, helical towers, belt links that technically are not magazines at all, but serve the same fundamental purpose. Each design is a response to a specific set of constraints: weight, capacity, reliability, cost, and the physics of the cartridge itself. To truly appreciate what we are about to explore, picture a table. On that table sits every significant magazine design in the history of firearms. You would need a very large table, because from the Spencer repeating rifle of 1860 to the Magpul D60 drum magazine of 2015, humanity has spent over 150 years obsessively refining the answer to a single question: how do we keep the gun shooting? The answer, as it turns out, is far more complex than anyone initially imagined. And the story behind each solution is soaked in war, politics, corporate rivalry, and the occasional flash of genuine genius. Some of these designs saved thousands of lives. Others cost thousands. A few were so brilliantly engineered that they remained unchanged for a century. And some were so catastrophically flawed that they were abandoned on battlefields by the soldiers forced to use them. Let us begin with definitions, because the firearms world is plagued by terminology that even experienced shooters routinely confuse. A magazine is a device that stores ammunition and feeds it into a firearms action. A clip is a device that holds ammunition together for insertion into a magazine. These are not the same thing. They have never been the same thing. And every time someone calls a magazine a clip, a firearms engineer somewhere quietly dies inside. The word magazine itself comes from the Arabic word makazin, meaning storehouse. The French adopted it as magazin, and the English military borrowed it to describe any place where ammunition or explosives were stored. A ship's magazine, a fort's magazine. Eventually, the term migrated to the small container attached to a firearm that stores its ready supply of cartridges. Etymology, it turns out, is loaded too. Broadly speaking, magazines fall into two master categories: integral and detachable. An integral magazine is built into the firearm itself. You cannot remove it without disassembling the weapon. The ammunition is loaded directly into the magazine through the action, either one round at a time or using a clip. Think of a bolt-action Mauser or a lever-action Winchester. The magazine is the gun. They are inseparable. A detachable magazine, by contrast, is a self-contained unit that can be removed and replaced. You load rounds into the magazine away from the weapon, carry multiple loaded magazines on your person, and when one runs empty, you drop it free and insert a fresh one. This is the paradigm that dominates modern firearms. The swap, the reload, the tactical reload, where you replace a partially spent magazine before it runs dry to maintain maximum capacity. Within those two master categories, there are dozens of subtypes, and this is where our journey truly begins. We will explore every single one of them, not just the common ones that fill gun store shelves, not just the famous ones that appear in war movies. Every type, the obscure, the experimental, the brilliant, the terrible, the ones that worked so well they defined entire eras of warfare, and the ones so flawed they were melted down for scrap within months of their creation. We will start with the simplest designs and work our way toward the most complex. Along the way, we will meet the engineers, soldiers, and visionaries who created them. We will examine the wars that demanded them, the failures that refined them, and the physics that constrained them. Because a magazine is never just a box of bullets. It is a thesis statement about what a weapon is supposed to do and how desperately its user needs it to keep doing it. So settle in. This is going to take a while, because the history of the gun magazine is, in many ways, the hidden history of modern warfare itself. Every major conflict of the last 160 years was shaped, in part, by the magazine technology available to the combatants. And understanding that technology means understanding why some armies marched forward while others were cut to pieces. Before the metallic cartridge, repeating fire was a dream pursued by optimists and madmen. Early attempts included the Calf repeater of the 1600s, a hideously complex flintlock with internal magazines for both powder and ball. Fewer than 100 were ever made, and each one cost more than a small house. Effective? Occasionally. Practical? About as practical as a chocolate teapot in a sauna. The Girandoni air rifle of 1779 came closer. Used by the Austrian army and famously carried on the Lewis and Clark expedition, this pneumatic repeater held 20 rounds in a tubular gravity-fed magazine. No gunpowder, no smoke, near silent operation. It was, in many ways, the first practical repeating weapon with a functional magazine. But it was fragile, expensive, and required a hand pump and 1,500 strokes to pressurize its air reservoir. The future of repeating fire would need a different power source. That power source arrived in the mid-1800s with the self-contained metallic cartridge, a brass case holding primer, powder, and projectile in a single waterproof, handleable unit. Suddenly, ammunition was modular. It could be stacked, stored, fed through a mechanism. The metallic cartridge did not just enable the magazine. It demanded it, because once you had a cartridge that a machine could handle, the obvious next step was to build a machine that handled many of them in rapid sequence. The Volcanic Repeating Arms Company, founded in 1855, took an early swing at this challenge with a lever-action pistol and rifle that used a tubular magazine loaded with rocket ball ammunition. The company itself failed rather spectacularly, but two of its investors would go on to change history. One was Oliver Winchester. The other was a shirt manufacturer named Smith, who would eventually partner with a man named Wesson. Sometimes the magazine story is really about who was sitting in the room when the idea first caught fire. The American Civil War became the first major conflict where magazine-fed weapons made a measurable difference. The Spencer repeating rifle, with its 7-round tubular magazine loaded through the buttstock, allowed Union cavalry and infantry to deliver a volume of fire that muzzle-loading Confederates simply could not match. A trained Spencer user could fire 14 aimed rounds per minute. His opponent, with a rifled musket, could manage perhaps 3. The mathematics of slaughter had shifted permanently. Confederate soldiers reportedly called the Spencer that damned Yankee rifle that you load on Sunday and shoot all week. The exaggeration was forgivable. When you're on the wrong end of a 4-to-1 fire superiority, 7 rounds probably does feel like it lasts all week. The Spencer's tubular magazine, for all its limitations, had proven something that military theorists had debated for centuries: volume of fire wins engagements. And the magazine was the key to volume of fire. But the Spencer's design had problems. Loading 7 rounds through the buttstock was slow and awkward. The tubular magazine limited the cartridge to rimfire, which in turn limited power. An entire concept of a tube magazine running through the stock imposed severe constraints on capacity. If you wanted more rounds, you needed a longer tube, which meant a longer stock, which quickly became absurd. The tube was a start, but the future belonged to a different geometry entirely. Meanwhile, across the Atlantic, European armies watched the American Civil War with intense professional interest. The lesson was clear. Repeating weapons with magazine feed were not toys. They were not novelties. They were the future. And the nation that mastered magazine technology first would hold a decisive advantage on every battlefield of the coming century. The arms race for the perfect magazine had officially begun. What followed was an explosion of innovation unlike anything the firearms world had ever seen. Between 1860 and 1900, more than 24 fundamentally different magazine concepts were patented, prototyped, and tested. Some worked. Many did not. A few were so ahead of their time that they would not be fully appreciated for another century. The age of the magazine had dawned, and every gunmaker on Earth was scrambling to find the design that would define the next era of combat. The tubular magazine is the oldest successful repeating firearm feed system still in widespread use today. Walk into any gun store in America, pick up a pump-action shotgun, and you're holding a weapon whose fundamental feeding mechanism was perfected during the presidency of Abraham Lincoln. That is not nostalgia. That is a testament to how profoundly right the original designers got the core concept, even if the details needed 160 years of polishing. The concept is elegant in its simplicity. A tube, usually running parallel to and beneath the barrel, contains cartridges arranged nose to tail in a single line. A spring at the closed end of the tube pushes the entire column of cartridges toward the action. When the action cycles, the frontmost cartridge is lifted from the tube and chambered. The spring pushes the remaining stack forward, and the next round takes its place in the feed position. No complex geometry, no double stack interleaving, just rounds in a line pushed by a spring. Benjamin Tyler Henry understood this principle when he designed the Henry rifle in 1860. The Henry used a 16-round tubular magazine running beneath its 24-inch octagonal barrel, loaded from the muzzle end of the tube through a complex slotted arrangement. The Henry was faster to fire than anything else on the Civil War battlefield. 16 rounds of .44 Henry rimfire, delivered as fast as the shooter could work the lever. In 1860, that was practically science fiction. But the Henry had a critical weakness, and it lived in that tubular magazine. The loading slot running along the underside of the tube was open and exposed. Dirt, mud, sand, and debris could enter freely and foul the magazine. In the manicured shooting ranges of Connecticut, this was manageable. In the trenches of Petersburg or the mud of Shiloh, it was a potentially lethal flaw. Soldiers stuffed rags into the slot. They carried the rifle with the tube pointed upward. They improvised constantly because the alternative was a jammed weapon at the worst possible moment. Oliver Winchester, who had acquired the Henry rifle's manufacturer, knew this had to be fixed. The result was the Winchester Model 1866, which solved the open slot problem by adding a loading gate on the side of the receiver. Now cartridges could be pushed into the magazine tube through a spring-loaded port in the receiver, and the tube itself was sealed along its entire length. It was a small change that transformed a fragile novelty into a rugged field weapon. The Yellow Boy, named for its distinctive brass receiver, became one of the most recognizable firearms in American history. The Winchester Model 1873 followed, and with it came the cartridge that would cement the lever-action's legend, the .44 Winchester centerfire. This was the first commercially successful centerfire cartridge designed specifically for a lever-action repeater, and its adoption by both the Winchester rifle and the Colt single-action Army revolver meant that a frontiersman could carry one caliber for both his rifle and his sidearm. The tube magazine had found its perfect ecosystem, and that ecosystem was the American West. Let us talk about the physics of the tubular magazine for a moment, because there's a constraint hidden inside that elegant tube that would eventually force rifle designers to abandon it entirely. In a tubular magazine, each cartridge sits directly behind the one in front of it. The bullet tip of one round presses against the primer of the round ahead. With flat-nosed or round-nosed bullets, this is perfectly safe. The contact area is broad and blunt. But what happens when you introduce a pointed, Spitzer-style bullet? The answer is recoil-induced detonation. When the rifle fires and recoils, the entire column of cartridges in the tube slams forward. If any cartridge has a pointed bullet tip, that point can strike the primer of the cartridge ahead of it with enough force to cause ignition. Inside a sealed steel tube packed with additional live rounds. The result would be catastrophic. A chain detonation that would destroy the magazine, the weapon, and very likely the shooter's hand and face. This is not theoretical. It is physics, and it is the reason tubular magazines are limited to flat-nosed, round-nosed, or specially designed elastomer-tipped ammunition. This limitation mattered enormously at the turn of the 20th century, when military ballistics was undergoing a revolution. The pointed Spitzer bullet, adopted by Germany in 1905 with the S. Patroni loading for the 7.92 by 57 mm Mauser, offered dramatically superior aerodynamic performance compared to round-nosed projectiles. Flatter trajectory, greater retained velocity, longer effective range. Every major military wanted Spitzer bullets, and Spitzer bullets were fundamentally incompatible with tubular magazines. The tube, for military rifle purposes, was finished. But the civilian world, and particularly the shotgun world, felt no such pressure. Shotgun shells use flat brass heads, and the payload, whether buckshot, birdshot, or a slug, sits inside a plastic or paper hull with a flat or gently rounded crimp at the front. There is zero risk of primer strike between shells and a tube. The tubular magazine was perfectly suited to shotgun ammunition, and it remains so to this day. Every pump action and most semi-automatic shotguns still use some variant of the tubular magazine that Benjamin Henry would immediately recognize. The Remington Model 870, introduced in 1950, is perhaps the ultimate expression of the tubular magazine shotgun. With over 11 million units produced, it is one of the most manufactured firearms in history. Its tubular magazine, running beneath a 26 to 28-inch barrel, typically holds 4 shells plus 1 in the chamber. The design is so reliable, so robust, and so inherently simple that it has been adopted by military forces, police departments, and hunters on every inhabited continent. The tube endures. The Mossberg 500 series, Remington's eternal rival in the pump-action market, uses an essentially identical tubular magazine concept, but adds its own refinements. The dual extractors, the top-mounted safety, the aluminum receiver that reduces weight. Both the 870 and the 500 have been in continuous production for over 7 decades. Together, they have sold more than 20 million units, all fed by tubes. Christopher Spencer and Benjamin Henry would be quietly astonished. Modern innovations have pushed the tubular magazine concept further than its inventors could have imagined. The Kel-Tec KSG, introduced in 2011, uses two parallel tubular magazines beneath a compact bullpup configuration, giving the shotgun a total capacity of 14 12-gauge shells, plus one in the chamber. A manual selector switch allows the operator to choose which tube feeds the action. It is, frankly, an absurd amount of shotgun in an absurdly compact package. The tube, it seems, still has tricks up its sleeve. The IWI Taver TS-12, released in 2019, took the concept even further with 3 rotating tubular magazines arranged in a triangular cluster. 15 rounds of 12-gauge, fed through a semi-automatic bullpup action. When one tube runs empty, the shooter rotates the next into position with a simple twist. It looks like something from a dystopian science fiction film, and it feeds like a dream. The tubular magazine, born in 1860, was still generating new patents 160 years later. There is one more tubular magazine variant worth examining before we move on. The underbarrel tube, found on lever-action rifles chambered in pistol calibers. The Marlin Model 1894, the Winchester Model 92, and their modern clones feed rounds like .357 Magnum, .44 Magnum, and .45 Colt from tubes that can hold 9 to 12 rounds. Because these pistol caliber cartridges use flat-nosed or hollow-point bullets, the primer detonation risk is eliminated. The lever-action pistol caliber carbine is, in essence, the last holdout of the tubular magazine in the rifle world. And what a holdout it is! The lever-action pistol caliber carbine has experienced a remarkable renaissance in the last 2 decades, driven partly by cowboy action shooting competitions and partly by the practical appeal of a lightweight, fast-handling rifle that shares ammunition with a belt-holstered revolver. Henry Repeating Arms, reviving the name that started it all, now produces more lever-action rifles than Winchester ever did at its peak. The 2-magazine cowboy gun is against all odds, thriving in the 21st century. Capacity remains the tubular magazine's fundamental limitation. Because rounds are stored in a single column, capacity scales linearly with tube length. Want more rounds? Make the tube longer. But a longer tube means a longer barrel shroud, more forward weight, and increased overall weapon length. The practical limit for a handheld shotgun is about 8 to 9 shells in a standard configuration. Extended magazine tubes, popular for competition shooting, can push past that, but at the cost of a weapon that handles like a fence post. Weight distribution is another consideration. A fully loaded tubular magazine places all of its ammunition weight forward of the action, creating a nose-heavy balance. As rounds are fired and the tube empties, the balance shifts rearward. This means the weapon handles differently when full versus empty, a characteristic that experienced shotgunners learn to compensate for instinctively, but that new shooters often find disconcerting. You are, in a very real sense, shooting a slightly different gun with every shell you fire. Reloading speed is perhaps the tube's greatest competitive disadvantage compared to detachable magazine systems. When a box magazine runs empty, you press a release, the empty magazine drops free, you insert a loaded magazine, and you are back in action. 2 seconds, perhaps 3. When a tubular magazine runs empty, you must feed rounds one at a time through the loading gate. Each shell takes roughly 1 to 2 seconds to load. Recharging a 7-round tube takes 7 to 14 seconds. In a defensive scenario, that is an uncomfortable eternity. Competitive shooters have developed extraordinary techniques to mitigate this disadvantage. Twin loading, where 2 shells are inserted simultaneously through the loading gate. Quad loading, an almost supernatural display of manual dexterity where 4 shells are indexed between the fingers and loaded in a single fluid motion. These techniques can cut reload times by 60 to 70%, but they require hundreds of hours of practice and a level of fine motor control that borders on the artistic. The tube demands skill that the box magazine does not. Despite its limitations, the tubular magazine has earned a permanent place in the firearms landscape. It is the simplest practical repeating mechanism. It has the fewest moving parts. It is the least susceptible to damage from drops and impacts, because the tube is a rigid steel cylinder with nothing to bend, crack, or deform. It requires no separate component to carry or potentially lose. And for shotguns, which fire relatively few rounds in most engagements, its capacity limitations are rarely a critical factor. The tube also offers a unique tactical advantage that is often overlooked: selective loading. Because rounds are inserted one at a time through the loading gate, a shotgun operator can change ammunition types on the fly. Start with buckshot, transition to slugs, mix in breaching rounds. This is impossible with a detachable box magazine, where the ammunition type is determined when the magazine is loaded. The tube's slow reload is, paradoxically, also its greatest source of tactical flexibility. So let us give the tubular magazine the respect it deserves. It was the first magazine that worked, the first that was adopted in large numbers, the first that proved on actual battlefields that a magazine-fed weapon could dominate a conflict. The lever-action rifles that won the West, the trench shotguns that cleared the trenches of World War I, the riot guns that defined American law enforcement for a century, all of them fed from tubes. It was never the most advanced design, but it was the one that started everything. If you could travel back in time and hand a single object to a military planner from the 1870s that would most dramatically accelerate the future of warfare, it would not be a nuclear bomb. It would not be a jet engine. It would be a 30-round STANAG magazine for the M16 rifle. Because that simple aluminum box, with its internal spring and anti-tilt follower, embodies every principle that would take the firearms world decades of bloody trial and error to discover. The detachable box magazine is the most transformative ammunition feeding device ever created. The story begins with a Scottish-Canadian immigrant named James Paris Lee. Born in Hawick, Scotland in 1831, Lee immigrated to Canada as a child and eventually settled in the United States, where he became one of the most prolific firearms designers of the 19th century. Lee held dozens of patents, but his most consequential invention was the detachable box magazine, first patented in 1879. It was, in the understatement of the century, a good idea. Lee's concept was deceptively straightforward. Take a box-shaped container, open at the top. Inside, place a spring-loaded platform called a follower. Stack cartridges on top of the follower, which pushes them upward. Attach the box to the underside of the rifle's receiver, positioned so that the topmost cartridge aligns with the bolt face. When the bolt moves forward, it strips the top round from the magazine and pushes it into the chamber. When the bolt retracts after firing, the spring pushes the next round up. Repeat until empty. Then remove the box and insert a full one. The British military recognized Lee's genius before anyone else. The Lee Metford rifle, adopted in 1888, was the first military bolt-action rifle to use a detachable box magazine as standard equipment. Its 10-round magazine, loaded with two 5-round charger clips, gave British soldiers double the ready ammunition of their closest competitors. When the Lee Enfield succeeded it in 1895, the 10-round box magazine carried over, and it would remain the standard British infantry magazine capacity through 2 world wars. The Lee Enfield's magazine system was brilliant in its execution. The magazine body was a simple pressed steel box with a zigzag follower spring that allowed 10 rounds to be stacked in 2 staggered columns. The double column, or double stack, arrangement was critical because it allowed greater capacity without proportionally increasing magazine length. A single column of 10 rounds would have produced a magazine extending absurdly below the rifle. 2 staggered columns cut that length nearly in half. Let's pause here and explain the difference between single stack and double stack magazines, because this distinction defines 2 entire families of box magazine design. A single stack magazine arranges cartridges in a single vertical column, one directly atop the other. The magazine is narrow, typically only slightly wider than the cartridge itself. This makes for a slim, easily gripped weapon, but limits capacity for a given magazine length. A double-stack magazine, by contrast, arranges cartridges in 2 offset columns that interleave like interlocking fingers. Each successive round sits slightly offset from the one below it, nestling into the gap between the two rounds beneath. This doubles the capacity for a given magazine length, but increases the magazine's width. Most modern military rifle magazines and the majority of full-size pistol magazines are double-stack. The width penalty is worth the capacity gain in almost every tactical context. There's a third variant that deserves mention: the double-stack, single-feed magazine. In this design, the cartridges are stacked in two columns inside the magazine body, but the columns converge to a single feed position at the top. Only one round at a time is presented to the bolt face. This is the most common design in pistol magazines and many rifle magazines, including the ubiquitous STANAG pattern. The convergence from double stack to single feed is achieved by tapering the magazine's internal geometry, and getting that taper exactly right is one of the most critical aspects of magazine engineering. Then there is the double stack, double feed magazine, where both columns present rounds to the action simultaneously, or rather, alternately. The bolt face strips round from the left column, then the right, then the left again. This design is mechanically simpler and somewhat more reliable at higher capacities, but it requires a more complex feed geometry in the receiver. The AK-47's iconic curved magazine is a double stack, double feed design. So are most belt-fed machine gun feed trays, conceptually speaking. Now, why is the AK-47 magazine curved while the M16 magazine is nearly straight? The answer lies in the cartridge. The 7.62 by 39mm round used by the AK-47 has significant taper. The base of the case is noticeably wider than the neck. When you stack tapered cartridges in a double column, the column naturally wants to curve. Forcing tapered cartridges into a straight magazine creates binding and feeding problems. So Mikhail Kalashnikov simply let the magazine follow the cartridge's natural geometry, and the result is that distinctive banana curve that has become one of the most recognized silhouettes in the world. The 5.56 by 45mm NATO cartridge used by the M16 and its derivatives has much less case taper, so its magazines are only slightly curved. The .45 ACP cartridge used by the M1911 pistol has almost no taper at all, and its single-stack magazine is virtually straight. The 9mm Parabellum has moderate taper, and its double-stack magazines show a gentle curve. Every box magazine, if designed correctly, is a physical expression of its cartridge's geometry. The ammunition dictates the magazine's shape. Always. The Mauser system, particularly the Gur 98 and its internal box magazine, deserves special attention in this chapter. Hall Mauser's controlled feed action, with its integral staggered column box magazine, set the standard for bolt-action rifle accuracy and reliability that persists to this day. The Mauser's magazine was not detachable in standard configuration. It was an integral part of the receiver, loaded from the top via 5-round stripper clips. But its internal geometry, the staggered double column feeding to a single position, was identical in principle to Lee's detachable design. The debate between integral and detachable box magazines consumed military planners for decades. The Germans and most continental European armies initially preferred integral magazines, arguing that detachable magazines could be lost, damaged, or would encourage soldiers to waste ammunition through rapid fire. The British, with their Lee Enfield, proved decisively that detachable magazines enabled faster reloading and higher sustained fire rates. The question was settled permanently in World War I, where the ability to quickly swap magazines under fire proved to be worth any number of theoretical disadvantages. World War II brought the box magazine into the semi-automatic and fully automatic era. The M1 Garand, America's legendary battle rifle, used an 8-round in-block clip that functioned as a type of internal box magazine. We will discuss in-block clips in detail later. But the weapons that truly defined the box magazine's dominance were the submachine guns. The Thompson with its 20 and 30 round box magazines, the Sten with its 32-round box, the MP40 with its 32-round double stack, and the PPSH-41 with its 35-round curved box. Each of these submachine gun magazines taught designers hard lessons about box magazine engineering. The Sten gun's magazine was notoriously unreliable. Its double-column, single-feed design was made from stamped steel to minimize cost, and the tight tolerances required for reliable feeding were often not met in mass production. British soldiers learned to load only 28 rounds in the 32-round magazine to reduce spring tension and improve reliability. A magazine that cannot be loaded to full capacity without jamming is, by any reasonable definition, a failed design. The Thompson's box magazines, by contrast, were overbuilt and expensive. Machined from solid steel bar stock, they were heavy, beautifully finished, and absurdly reliable. But they cost more to manufacture than many complete weapons. The tension between reliability and manufacturing cost would define box magazine development for the next 80 years. The perfect magazine feeds flawlessly, costs nothing to make, weighs nothing, and holds infinite rounds. No one has achieved this yet, but not for lack of trying. The post-war era saw the box magazine achieve total dominance in military rifle design. The AK-47, adopted by the Soviet Union in 1949, used a 30-round curved steel box magazine that became the template for every subsequent assault rifle magazine in the Eastern Bloc. Robust, cheap to manufacture, and tolerant of appalling conditions, the AK magazine's slab steel construction and generous internal clearances made it one of the most reliable feeding devices ever mass-produced. You could fill it with sand, shake it out, load it, and it would probably still work. Probably. On the Western side, the story was more complicated. The M16 rifle, adopted by the United States military in the 1960s, initially shipped with 20-round aluminum box magazines. These early magazines were adequate but uninspired. The real problem came when the military demanded a 30-round version. The resulting 30-round aluminum magazine, with its distinctive gentle curve and bright finish, would become the most produced detachable magazine in Western military history. It would also become one of the most controversial. The original 30-round M16 magazine used a simple flat follower that could tilt inside the magazine body under spring pressure. When the follower tilted, rounds could nosedive rather than feeding smoothly upward, causing the dreaded failure to feed malfunction. This problem plagued the M16 platform for decades. Soldiers taped magazines together for faster swaps. They downloaded magazines to 28 rounds. They obsessively maintained their magazine springs. And they cursed, quietly and creatively, every time a follower tilted and a round dove. The solution, when it finally arrived, was almost embarrassingly simple. In the 2000s, the United States Marine Corps developed the improved magazine with a tan-colored anti-tilt follower. The follower's geometry was redesigned with self-leveling features that prevented it from cocking sideways inside the magazine body. A stainless steel spring replaced the older music wire spring, and the reliability improvement was dramatic. Feed-related malfunctions dropped by over 50% in field testing. A half-century of frustration solved by a slightly different shaped piece of plastic. Magpul Industries, founded in 1999, would push the box magazine even further with the introduction of the PMAG, a polymer-bodied magazine that has become the de facto standard for AR-15 pattern rifles worldwide. The original PMAG, released in 2007, used a proprietary polymer body that was lighter than aluminum, more resistant to impact damage, and included a built-in anti-tilt follower and a constant curve internal geometry that dramatically improved feeding reliability. It cost about $12. Within 5 years, it had captured the majority of the civilian AR-15 magazine market. The PMAG's success was not just about materials. It was about understanding what made box magazines fail. Magpul's engineers identified that most feeding failures occurred in the last few rounds of the magazine, when the spring was most compressed and the follower had the least mechanical advantage. They redesigned the internal rib geometry to guide the follower more precisely. They altered the feed lip geometry to present rounds at a more consistent angle. They made the feed lips from the same polymer as the body, trading the aluminum magazine's feed lip durability for a slight improvement in feed angle consistency. The result was a magazine that simply worked with monotonous reliability in conditions that would choke an aluminum magazine. Let us talk about STANAG for a moment, because it is one of the most important and most misunderstood acronyms in the firearms world. STANAG stands for Standardization Agreement, and STANAG 4179 specifically defines the dimensional standards for a 5.56mm NATO rifle magazine. Any magazine built to STANAG 4179 specifications should fit and feed in any STANAG-compatible rifle. The M16, M4, 416 Hong Kong dollars, FN SCAR-L, Steyr August NATO, and dozens of other rifles all accept STANAG pattern magazines. It is, in effect, the USB standard of the firearms world. The genius of STANAG is interoperability. On a NATO battlefield, a French soldier with a FAMAS can pick up a magazine dropped by a Canadian with a C7 and use it in his own weapon. An American Marine can borrow magazines from a British Royal Marine. A Norwegian conscript can resupply from a Polish ammunition dump. This logistical flexibility is enormously valuable in coalition warfare, and it was achieved by something as mundane as agreeing on the exterior dimensions of a metal box. Sometimes the most consequential engineering decisions are the most boring ones. The pistol box magazine has its own parallel evolution that deserves attention. The Browning High Power of 1935 was the first widely adopted military pistol to use a double-stack magazine, with a 13-round capacity that was nearly double the 7 to 8 rounds typical of single-stack designs like the M1911. The High Powers magazine was a masterpiece of compact engineering, stacking 9mm parabellum rounds in a column that was only marginally wider than a single stack but held nearly twice the ammunition. Modern double-stack pistol magazines have pushed capacities to levels that would have astonished John Moses Browning. The Glock 17, introduced in 1982, carries 17 rounds of 9mm in its standard magazine. The Sig Sauer P3 20 carries 17 to 21 rounds, depending on the frame size. The Smith & Wesson M and P5.7 carries 22 rounds. The FN 5.7 carries 20. All of these are standard capacity, factory-produced magazines. The box magazine, in pistol form, has made the revolver's 6-round cylinder look quaint by comparison. The box magazine story is, in many ways, the story of modern firearms themselves. From James Paris Lee's 1879 patent to the latest generation polymer magazine with anti-tilt followers and constant curve geometry, the fundamental concept has remained unchanged for nearly 150 years. A box, a spring, a follower, round stacked vertically. It is so simple that it seems inevitable. But it took a Scottish-Canadian immigrant to see it clearly, and it took the rest of the world decades to refine his vision into the feeding devices that equip every modern military on Earth. There is something almost obscene about a drum magazine. Where the box magazine is restrained and utilitarian, the drum is excessive, gluttonous even. It says, I do not want 30 rounds. I want 50, 75, 100. I want to hold down the trigger and watch the world come apart at the seams. The drum magazine is the firearms equivalent of ordering the entire dessert menu. You probably do not need all of it, but the sheer audacity of having it is deeply, irrationally satisfying. The concept of the drum magazine dates back further than most people realize. The earliest functional drum design was the trommel magazine, developed for the Luger P08 pistol and the artillery Luger variant in 1917. This 32-round snail drum used a coiled spring to push 9mm parabellum rounds through a spiral channel and into the pistol's action. It was designed to give the long-barreled artillery Luger, used as a quasi-carbine in trench warfare, enough sustained fire to be tactically relevant. It worked, barely. The trommel magazine was a nightmare to load. Rounds had to be inserted one at a time into the spiral channel, each one fighting against the coiled spring's increasing tension. A special loading tool was provided, without which the magazine was essentially impossible to fill. Even with the tool, loading 32 rounds took several minutes of concentrated effort, and once loaded, the spring was under enormous tension, which caused feeding problems if the magazine was left loaded for extended periods as the spring took a set and lost its force. But the Trommel magazine proved a concept. You could store a large number of rounds in a compact circular form factor and feed them through a single outlet. The spiral path was longer than a straight box, but the circular geometry meant the magazine did not extend far below the weapon. For a pistol or submachine gun, where a long box magazine dangling beneath the grip was both unwieldy and prone to damage, the drum offered a compelling alternative. The circle was the answer. The trick was making the circle reliable. The Thompson submachine gun, designed by General John T. Thompson and first produced by Auto Ordnance Corporation in 1919, would make the drum magazine famous. The Thompson was originally offered with two magazine options, a 20-round box magazine, later a 30-round box, and the Type C 50-round drum magazine. A larger Type L drum held 100 rounds, but was so heavy and unreliable that it was rarely used. The 50-round drum became the Thompson's iconic configuration, the one seared into the public consciousness by Prohibition-era gangsters and Hollywood. The Type C drum worked on a rotor principle. Rounds were arranged in a spiral pattern inside a flat cylindrical housing. A wound clock spring in the center of the drum provided rotational force, pushing the rounds along the spiral channel and out through a feed tower that mated with the Thompson's receiver. The system was cleverly designed, mechanically interesting, and absolute murder to load. Owners needed a special winding key to tension the spring, and the loading process involved carefully indexing each round into the spiral while maintaining spring tension. Get it wrong, and rounds would jam spectacularly. During Prohibition, the Thompson with its drum magazine became the weapon of choice for bootleggers, bank robbers, and organized crime figures. This St. Valentine's Day massacre of 1929 cemented the drum-fed Thompson as a symbol of lawless violence. Al Capone's enforcers reportedly used Thompson guns with 50-round drums to execute 7 members of the rival Bugs Moran gang in a Chicago garage. The drum magazine, designed for trench warfare, had found its most famous application in an entirely different kind of combat. The United States military adopted the Thompson in 1938 as the M1928A1, and it served throughout World War II. But the military quickly discovered what gangsters had learned the hard way. The drum magazine was problematic in field conditions. It rattled loudly, betraying the soldier's position. It was heavy, adding nearly 2 pounds to the weapon when loaded. It was slow to reload, and it jammed with distressing frequency when exposed to dirt, sand, or moisture. Within months of combat deployment, most frontline units had abandoned the drum in favor of the 30-round box magazine. The Soviet Union took a different approach to the drum magazine with the PPSH-41, designed by Georgy Shpagin and adopted in 1941. The PPSH-41's 71-round drum magazine was a simplified version of the Finnish Suomi KP-31 drum, itself one of the most successful drum designs ever created. The Suomi drum used a 4-column feed system with a complex but highly reliable internal mechanism. Shpagin adapted this concept for mass production, creating a drum that was simpler to manufacture but retained much of the Suomi's feeding reliability. The PPSH-41 drum held 71 rounds of 7.62 by 25 mm Tokarev, a small, fast, bottleneck pistol cartridge that was well suited to drum feeding. Soviet doctrine called for mass submachine gun fire, with entire companies armed exclusively with PPSH-41s charging enemy positions while hosing them with automatic fire. The drum magazine was essential to this doctrine, providing the sustained fire volume needed to keep enemy heads down during the final assault. In Stalingrad, soldiers with drum-fed PPSH-41s became the lords of close quarter-urban combat. But even the PPSH-41 drum had its problems. Loading was tedious and time-consuming. The drums were heavy, and soldiers often carried only one drum plus several 35-round box magazines. The drums were also sensitive to the condition of their internal spring. A weak spring meant sluggish feeding and failures. An overwound spring could cause rounds to be pushed with excessive force, leading to double feeds. There was a sweet spot, and finding it required experience and a certain intuitive feel for the mechanism. Soviet soldiers who survived long enough to develop that intuition were worth their weight in gold. The Chinese Type 56, a copy of the PPSH-41 produced in enormous quantities from the 1950s onward, continued the drum magazine tradition and carried it into conflicts across Asia, Africa, and the Middle East. Chinese drums were often of lower manufacturing quality than their Soviet predecessors, exacerbating reliability issues. But they were cheap, plentiful, and when they worked, they provided a devastating volume of fire that compensated for many shortcomings. In the Korean War and the Vietnam War, American forces became grimly familiar with the sound of drum-fed PPSH and Type 56 fire. The RPK, the Soviet squad automatic weapon variant of the AK-47 platform, introduced a different style of drum magazine. The RPK's 75-round drum, adopted in the 1960s, used a back-to-back dual rotor design where rounds were stored in two concentric spiral channels. This design distributed the spring tension more evenly and provided more consistent feeding than single rotor designs. The RPK drum became the standard high-capacity magazine for the AK platform and remains in widespread service today. Let's talk about the engineering challenges that make drum magazines inherently more complex and less reliable than box magazines. The fundamental problem is the transition from circular to linear. Rounds stored in a curved or spiral channel must be redirected into a straight line to feed into the weapon's action. This transition point, where the curved magazine channel meets the straight feed tower, is where most drum magazine failures occur. Rounds can nose dive, tilt, or stack up at this junction if the geometry is even slightly wrong. Spring design is another critical challenge. A box magazine uses a relatively simple compression spring or zigzag spring that pushes straight up. A drum magazine uses a coiled torsion spring or clock spring that provides rotational force. This rotational force must be calibrated to the number of rounds in the drum, the friction of the cartridges against the drum's internal walls, and the feed resistance of the weapon's action. Too much spring force early in the drum, and you get feeding problems with the first rounds. Too little spring force at the end, and the last rounds fail to feed. The spring must deliver consistent force across the entire capacity range, and that is extremely difficult to achieve with a coiled spring. Weight is the drum's most obvious disadvantage. A loaded 75-round RPK drum weighs approximately 2.7 kilograms. A loaded 30-round AK-47 box magazine weighs about 0.9 kilograms. 3 box magazines equal 90 rounds and weigh 2.7 kilograms, the same as one 75-round drum. But 3 box magazines give you 15 more rounds, can be distributed across your load-bearing equipment instead of concentrated in one heavy lump, and each one can be reloaded independently if one is damaged. The weight equation almost always favors the box. Noise is another issue that drum users learn about the hard way. A loaded drum magazine, with its round arranged in a spiral channel, tends to rattle. Each round has a small amount of free play inside the channel, and when the soldier moves, the rounds shift and clink against each other and against the drum's walls. In a firefight, this noise is irrelevant. On a patrol in hostile territory, trying to move silently through brush or urban terrain, a rattling drum announces your presence with the subtlety of a marching band. Special operations forces, for this reason, almost universally avoid drum magazines. Despite these disadvantages, the drum magazine has never been abandoned because it offers one thing that no other magazine type can match: raw, sustained volume of fire from a weapon light enough for one person to carry and operate. A 100-round drum on a light machine gun or an infantry automatic rifle means the gunner can provide suppressive fire for longer before reloading. In the suppressive fire role, where the point is not to hit a specific target, but to make an area uninhabitable for the enemy, the drum is king. The Beta Company C Mag, patented in 1987 by Jim Sullivan, one of the original M16 design team members, attempted to solve many of the drum's reliability problems. The C Mag uses a dual drum configuration, with two circular drum modules connected by a central feed tower. Rounds feed alternately from each drum, which distributes the mechanical load and provides more consistent spring tension. The result is a 100-round magazine with reliability that approaches, though does not quite match, a standard box magazine. The C Mag's clever dual drum design creates a rough figure-8 profile when viewed from the front. Each drum module is about the size of a large orange, and the loaded magazine weighs approximately 2.1 kilograms. It requires careful loading using a provided loading tool, and the manufacturer recommends winding the internal spring a specific number of clicks after loading to achieve optimal tension. All of this adds complexity, but 100 rounds of 5.56 millimeters in a single package that fits a standard STANAG magazine well, for certain applications, the complexity is worth it. The Magpul D60, released in 2015, represents the current state-of-the-art in drum magazine design for the AR-15 platform. Holding 60 rounds of 5.56 millimeters NATO in a single rotor drum with a polymer body, the D60 is lighter than comparable capacity drums and easier to load. No winding tool is required. The internal ratcheting mechanism automatically tensions the spring as rounds are loaded. And in extensive testing by both military and civilian users, the D60 has demonstrated reliability approaching that of a standard 30-round PMAG. Approaching, but still not quite matching. The X Products X15, another modern drum for the AR-15 platform, takes a different approach entirely. Instead of a traditional rotor design, the X15 uses a skeletal aluminum drum body with visible internal rounds. It holds 50 rounds and has earned a reputation for exceptional reliability, partly because its open design sheds dirt and debris rather than trapping it inside a sealed housing. It looks like a mechanical art piece, and it feeds like a dream. Shotgun drums deserve their own mention in this chapter. The Saiga 12-gauge shotgun, a Kalashnikov-patterned semi-automatic shotgun, accepts a variety of drum magazines ranging from 10 to 30 rounds. A 30-round drum of 12-gauge buckshot is, objectively, one of the most devastating close-range weapon configurations ever devised by human beings. It is also one of the heaviest and most unwieldy. A loaded 30-round 12-gauge drum weighs roughly as much as a small dog. But what it lacks in grace, it compensates for in sheer, thunderous, wall-destroying firepower. The drum magazine occupies a peculiar place in the firearms ecosystem. It is simultaneously impressive and impractical. Beloved by recreational shooters for the sheer fun of sustained fire. Tolerated by military users who need suppressive fire volume. Avoided by professionals who prioritize reliability and weight. And romanticized by popular culture, which has made the drum-fed submachine gun an icon of both gangster chic and apocalyptic preparation. The drum is not the best magazine for most purposes, but for its specific purpose, providing maximum rounds in a single package, nothing else comes close. As we leave the drum behind, it is worth noting that the fundamental engineering challenge of the drum, storing many rounds in a compact form factor and feeding them reliably, has been attacked from dozens of different angles over the past century. Some of those approaches are so unusual, so mechanically creative, that they deserve their own chapter. The rotor, the helix, the pan, the saddle. Each one is a different answer to the same question that has driven magazine designers since the beginning. How do we fit more rounds in a less space? Not every magazine designer looked at the box and thought make it bigger. Some looked at it and thought make it smarter. The rotary magazine is the product of that second instinct. Instead of stacking rounds in a vertical column or coiling them in a flat spiral, the rotary magazine arranges them radially around a central spool, like spokes on a wheel. Each round sits in its own individual pocket in the spool. When the spool rotates, it brings the next round into alignment with the feed position. It is compact, elegant, and strangely beautiful in its mechanical precision. The rotary magazine concept dates back to Ferdinand Mannlicher, the Austrian firearms genius who patented dozens of feeding mechanisms in the late 1800s. Mannlicher's rotary spool magazine used a star-shaped rotor with pockets machined to hold individual cartridges. As the bolt moved forward, it stripped a round from the rotor pocket and chambered it. The bolt's return stroke rotated the spool to bring the next round into position. The system was smooth, positive, and remarkably reliable for its era. Mannlicher, who patented more firearms mechanisms than almost anyone in history, considered it one of his best ideas. The most famous application of Mannlicher's rotary concept came not from Mannlicher himself, but from Arthur Savage. The Savage Model 99, introduced in 1899, used a rotary magazine that held 5 rounds of high-powered rifle ammunition in a spool located within the receiver. Unlike a box magazine, which extended below the stock, the Model 99's rotary magazine was entirely flush with the receiver bottom. This gave the rifle a clean, streamlined profile with nothing to snag on brush, clothing, or saddle scabbards. For hunters and outdoorsmen, this was a significant practical advantage. The Model 99 also solved the tubular magazine's pointed bullet problem. Because rounds in a rotary magazine sit in individual pockets, no bullet tip ever contacts another cartridge's primer. Spitzer bullets could be safely used in a lever-action rifle for the first time. The Savage 99 chambered rounds like the .250 3000 Savage and the .300 Savage, both using pointed bullets that would have been suicidal to load in a Winchester's tube. Savage had found a way to marry lever-action speed with modern ballistic performance, and the rotary magazine was the key. The Savage 99 remained in production for nearly a century, from 1899 to 1998. That is an almost unheard-of production run for any consumer product, let alone a firearm. The rotary magazine was a significant factor in its longevity because it offered capabilities that no other lever action could match. Pointed bullets, flush profile, and a mechanical round counter on the side of the receiver that told the shooter exactly how many rounds remained. You could glance at the counter and know whether you had 1 round left or 5. In an era before transparent magazines and bolt-hold open devices, that was genuinely innovative. The rotary magazine found its most commercially successful modern home in the Ruger 10/22 rifle, introduced in 1964. Bill Ruger, the legendary founder of Sturm Ruger and Company, designed a 10-round rotary magazine for this semi-automatic .22 long rifle that has become one of the most recognized magazine designs in the world. The Ruger 10/22 rotary magazine uses a molded polymer body with a spring-loaded rotor that indexes rounds through precisely machined pockets. It is flush-fitting, dirt-resistant, and extraordinarily reliable with the small, low-powered .22 LR cartridge. Over 60 million Ruger 10/22 rotary magazines have been produced, making it the most manufactured rotary magazine in history by an enormous margin. The design has been so successful that other manufacturers, including Browning with its BL-22 lever action and several European rifle makers, have adopted similar rotary mechanisms for their .22 caliber rifles. For small, rimfire cartridges, the rotary magazine offers an ideal combination of compactness, reliability, and flush fit aesthetics that box magazines struggle to match. But the rotary magazine has a fundamental limitation: capacity. Because rounds are arranged radially around a central spool, increasing capacity means increasing the spool's diameter. A 5-round spool for a full power rifle cartridge is already quite wide. A 10-round spool would be enormous, and a 30-round spool would be comically, uselessly oversized. The rotary magazine is inherently a low to moderate capacity design, best suited for bolt-action rifles, sporting semi-automatics, and small-caliber weapons where 5 to 10 rounds is sufficient. Some designers looked at this capacity limitation and had a radical thought. What if instead of arranging rounds radially around a flat spool, you arrange them helically around a long cylinder? Stack them in a spiral, like threads on a screw, and the capacity could be enormous within a relatively narrow diameter. This is the helical magazine, and it is one of the strangest, most mechanically ambitious feeding devices ever devised. The Calico M960 submachine gun, designed in the 1980s, is the most famous weapon to use a helical magazine. Its 50-round and 100-round helical magazines are cylindrical tubes that mount on top of the weapon, running along the length of the barrel. Inside, 9mm parabellum cartridges are arranged in a helical pattern, like a spiral staircase inside a lighthouse. A wound spring provides rotational force, and rounds travel through the spiral channel to a feed point at the rear of the magazine, where they drop into the action. It looks like nothing else on Earth, and it feeds like nothing else either, for better and for worse. The Calico's 100-round helical magazine is a cylinder roughly 16 inches long and 3 inches in diameter. It holds 100 rounds of 9mm in a space only slightly larger than two 30-round box magazines taped together. The weight distribution is unusual, with the magazine sitting on top of the weapon rather than below it, which gives the Calico a unique handling profile. The sights are offset to the side to clear the magazine body. The overall aesthetic is deeply, unmistakably 1980s. Angular, aggressive, and looking like it was designed by someone who watched too many science fiction films. Reliability was the Calico's persistent challenge. The helical feed path is long and complex, with numerous points where a round can tilt, jam, or fail to index properly. The wound spring must provide consistent force across the entire 100-round spiral, which is extraordinarily difficult. And the magazine's construction required tight tolerances that were expensive to maintain in production. Early Calico magazines had a reputation for frequent misfeeds that bordered on the comedic. Later production improved significantly, but the Calico never fully escaped its reputation as a weapon that was more impressive on paper than in practice. The Soviet Union explored helical magazines with the PP-19 Bison, a submachine gun designed in the early 1990s by Viktor Kalashnikov, son of the legendary Mikhail. The Bison uses a 64-round helical magazine that mounts beneath the barrel, essentially replacing the handguard. Rounds spiral through the cylindrical magazine from rear to front, and the magazine itself serves as the forward grip. It is a clever integration of magazine and ergonomics that is typically Russian in its pragmatic brutality. The Bison's helical magazine is more robust than the Calico's, partly because of its simpler internal geometry, and partly because the 9x18mm Makarov cartridge is shorter and less tapered than the 9x19mm Parabellum. The shorter cartridge allows for a more compact spiral with less opportunity for misalignment. Russian special forces, including various interior ministry units and police tactical teams, used the Bison extensively through the 1990s and 2000s. It was not elegant, but it worked well enough in the brutal, close-quarters engagements that defined Russian domestic counterterrorism operations. There is a third helical design worth mentioning: the Evans repeating rifle of 1871. Yes, 1871, nearly a century before the Calico. A Maine inventor named Warren Evans designed a lever-action rifle with a helical magazine in the buttstock that held an astonishing 34 rounds of its proprietary .44 Evans cartridge. The magazine used an Archimedean screw mechanism to advance rounds from the stock into the receiver. It was genuinely ahead of its time. So far ahead, in fact, that the manufacturing technology of the 1870s could not produce it with the consistency needed for reliable operation. The Evans rifle was tested by the United States Navy, which found it mechanically fascinating but practically unreliable. Fewer than 15,000 were produced before the company went bankrupt. The proprietary cartridge died with it. But the concept of helical ammunition storage in the buttstock was sound, and it would be rediscovered and re-engineered multiple times over the next century. Warren Evans, had he been born 100 years later with access to CNC machining and modern metallurgy, might have changed the entire trajectory of magazine design. The rotary and helical magazines share a common ancestor in their thinking. They both reject the straight line. The box magazine says rounds should stack vertically. The rotary says they should pinwheel around a hub. The helical says they should corkscrew through a cylinder. Each approach trades simplicity for some other advantage, whether it is flush fit, high capacity, or compact dimensions. And each approach introduces its own unique set of engineering challenges that must be solved for the design to function. The Steyr August, the Austrian bullpup rifle adopted in 1977, uses an interesting hybrid approach. Its standard magazine is a transparent polymer double-stack box, but the AUG's receiver is designed to accept a variety of magazine types, including the Steyr 42-round extended magazine. The AUG's transparent magazine was one of the first to allow the shooter to visually confirm remaining ammunition, a concept so obvious in retrospect that it is remarkable no one implemented it earlier. Sometimes the most impactful innovations are not about geometry at all. They're about simply being able to see what is going on inside the box. Lancer Systems took the transparent magazine concept further with their L5 Advanced Warfighter magazine, a hybrid design using a steel feed lip section bonded to a translucent polymer body. The steel lips solved the polymer feed lip durability concern that had always shadowed the PMAG, while the transparent body allowed visual round counting. It was an elegant compromise, the reliability of steel where it mattered most, combined with the weight savings and visibility of polymer everywhere else. The L5 earned a devoted following among competitive shooters and military special operations units. The Schmeisser Company of Germany, the same name associated with the MP-18 and erroneously with the MP-40, has produced a 60-round polymer drum magazine for the AR-15 platform that uses a modified rotary concept internally. Rather than a traditional spiral drum, the Schmeisser uses a series of nested rotary chambers that index rounds through a compact circular path. It is an interesting synthesis of rotary and drum principles, and it demonstrates that the boundaries between magazine types are not always as rigid as textbook classification suggests. Before we leave rotary and helical designs behind, there is one more experimental concept worth examining: the Pan magazine. Used most famously on the Lewis gun of World War I, the Pan magazine is a flat circular magazine that sits on top of the weapon. Rounds are arranged radially in the pan, tips pointed inward, and they are fed into the action through a central opening. The Lewis gun's 47-round and 97-round pans were among the most distinctive magazine profiles of the Great War, giving the weapon a flying saucer silhouette that was unmistakable on the battlefield. The Lewis gun's pan magazine worked by using the weapon's gas system to rotate the pan after each shot. A stud on the bolt engaged a cam track on the pan, and each cycle of the action rotated the pan by one cartridge position. This was a mechanically elegant solution that required no internal spring in the pan itself. The pan was simply a container with pockets for rounds, rotated by the weapon's own action. When it ran empty, the gunner lifted the pan off the weapon, placed a full one on, and continued firing. Reloads took about 5 seconds, which was remarkably fast for a light machine gun of the era. The Degtyaryov DP-28, the Soviet light machine gun of World War II, used a similar top-mounted pan magazine holding 47 rounds of 7.62x 54 mmR. The DP-28 pan was simpler than the Lewis pan, using a wound clock spring to rotate the pan rather than relying on the weapon's action. This made it more mechanically independent, but also more susceptible to spring fatigue. Soviet soldiers learned to carry spare springs and to replace them regularly, because a weak pan spring meant a weapon that fired a few rounds and then stopped feeding. In the middle of the Eastern Front, that was not ideal. The pan magazine, like the drum and the helical, is a high-capacity solution that trades simplicity for volume. Its flat profile makes it ideal for top-mounted applications where the shooter needs to maintain a low profile but it adds significant height to the weapon and prevents the use of conventional sights unless they are offset or raised. The pan has largely been abandoned in modern firearms design, replaced by belt feeds for sustained fire weapons and box magazines for individual weapons. But its ghost lives on in every top loading magazine design, a circular reminder that sometimes the most creative solutions are the ones that put the ammunition where you least expect it. As we move beyond the rotary, the helical, and the pan, we enter the realm of truly sustained fire. Everything we have discussed so far, tubes, boxes, drums, spools, and spirals, shares a common limitation: finite capacity within a self-contained unit. At some point, the magazine runs empty, and a shooter must pause to reload or swap. But what if the ammunition supply was effectively continuous? What if, instead of a sealed container, the feed system was an open chain of linked cartridges that could be made as long as you wanted? That is the belt feed, and it plays by entirely different rules. Everything we have discussed so far has been a container. A tom, a box, a drum, a spool, a spinnerøl. Something with walls. Something sealed. The belt feed system throws that entire paradigm out the window. It is not a container at all. It is a chain. An open, exposed, dangling chain of linked cartridges that feeds into the weapon from outside, one link at a time, and is either spat out the other side or disintegrates into individual segments as each round is stripped and fired. It is brutally simple in concept and ferociously complex in execution. The belt feed predates every magazine type we have covered so far, at least in its most primitive form. The Gatling gun of 1862 experimented with gravity-fed hoppers and early belt systems to supply its rotating barrels. But the true father of the modern belt feed is Hiram Maxim, the American-born British inventor who patented the first fully automatic, recoil-operated, belt-fed machine gun in 1884. The Maxim gun used a fabric belt, essentially a cloth strip with pockets sewn into it at regular intervals, each pocket holding a single cartridge. The gun's action pulled the belt through the feed mechanism, stripping each round from its fabric pocket and chambering it. Those fabric belts were, to put it charitably, temperamental. They absorbed moisture and swelled, causing feeding failures. They frayed and tore under the mechanical stress of high-speed feeding. They could not be easily reloaded in the field, and they were not reusable in any practical sense. But they worked well enough to demonstrate that a belt-fed weapon could sustain fire for as long as ammunition was available, which was a fundamentally different proposition than any magazine-fed weapon. A magazine has a fixed capacity. A belt can be as long as your ammunition supply allows. The Battle of Omdurman in 1898 demonstrated the belt feed's potential with horrifying clarity. British forces, equipped with Maxim guns fed by 250-round fabric belts, faced a Sudanese Mahdiist army of approximately 50,000 warriors armed primarily with swords, spears, and obsolete rifles. In 5 hours of fighting, the Maxim guns killed an estimated 10,000 Mahdiist fighters, while suffering fewer than 50 British dead. Winston Churchill, who was present as a young cavalry officer, later wrote that the battle was the most signal triumph ever gained by the arms of science over barbarians. The belt feed had made sustained, mechanical slaughter possible on an industrial scale. World War I transformed the belt feed from a colonial weapon into the defining technology of industrial warfare. The machine guns of Verdun, the Somme, and Passchendaele were almost universally belt-fed. Maxim's, Vickers MG08S, Hotchkiss guns. They consumed ammunition at rates that would have been inconceivable a generation earlier. A single Vickers gun could fire 10,000 rounds in an hour of sustained fire, if properly cooled and supplied. 10,000 rounds from a single weapon. No magazine in the world could support that rate of consumption. Only the belt could feed that hunger. The transition from fabric belts to metallic link belts began in earnest during the interwar period. The metallic links solved virtually every problem that plagued fabric belts. Links did not absorb moisture. They did not fray. They were dimensionally consistent. And depending on the link type, they could be reloaded and reused. The two fundamental types of metallic links, disintegrating and non-disintegrating, would define belt feed design for the next century. A non-disintegrating link belt, also called a continuous belt, is a permanent chain. Each link is a reusable metal clip that holds one cartridge but remains connected to the links on either side after the round is stripped. The empty belt exits the weapon intact and can be reloaded with fresh rounds. The German MG-34 and MG-42, the most fearsome machine guns of World War II, used non-disintegrating belts in 50-round segments that could be linked together to form longer belts. A 250-round belt was standard, but belts of 500 or even 1,000 rounds were assembled for defensive positions. The metallic clatter of a belt being fed into an MG-42 was one of the most terrifying sounds on the Western Front. A disintegrating link belt works differently. Each link is a separate piece of stamped metal that holds one cartridge and connects to the adjacent links through the cartridges themselves. When a round is stripped from the belt, the links on either side separate and fall away as individual pieces. The belt literally disintegrates as it feeds, leaving a trail of empty links and a pile of spent casings. The advantage is that there is no empty belt to manage. It simply vanishes as it is consumed. The disadvantage is that links cannot be easily reloaded in the field, and the falling links create a mess of metal debris around the weapon. The M13 link, standardized by NATO, is the most widely used disintegrating link in the Western world. It feeds the M60, M240, and M249 machine guns, among others, and it holds 7.62 by 51 mm NATO cartridges. The M27 link performs the same function for 5.56 by 45 mm NATO ammunition. Both are stamped from spring steel, phosphate-coated for corrosion resistance, and designed to be assembled into belts using manual or mechanical linking machines. A skilled soldier with a hand-cranked linking machine can assemble approximately 200 rounds of belted ammunition per minute. Faster if he has been doing it for a while, and slower if he is thinking about what those rounds will eventually be used for. Now, let us examine how a belt feed mechanism actually works inside the weapon, because this is where the engineering becomes genuinely impressive. The belt enters the weapon through a feed tray, a flat metal platform on top of or beside the receiver that supports and guides the belt. The belt is pulled across the feed tray by a feed mechanism, typically a set of pawls, which are spring-loaded claws that engage the belt links and advance them by one position with each cycle of the action. The pawls are driven by the bolt carrier or operating rod, so the weapon's own cycling energy is what pulls the belt through. In a push-through feed system, used by weapons like the M60 and PKM, the bolt pushes a cartridge forward out of the belt link and directly into the chamber. The link is left behind on the feed tray and ejected to the side. This is mechanically simpler and allows for a more compact action, but it requires significant bolt energy to push the cartridge through the link's retention tabs. The advantage is that the round moves in a straight line from belt to chamber, minimizing the opportunity for misalignment. In a two-stage feed system, used by weapons like the M2 Browning heavy machine gun, the process is more complex. First, the bolt strips the cartridge rearward out of the belt link, pulling it down and behind the link. Then, on the forward stroke, the bolt pushes the cartridge forward into the chamber. This two-step process allows for a more positive extraction from the belt and works better with large, heavy cartridges like the .50 BMG. But it requires a longer, heavier bolt carrier and a more complex feed mechanism. The M2 Browning has been using this system since 1933, and it has fired more .50 caliber rounds than any other weapon in history. The MG-42, arguably the most influential belt-fed weapon ever designed, introduced a feed mechanism that is still studied by engineers today. Its roller-locked bolt and open bolt firing system could sustain a cyclic rate of 1,200 rounds per minute, which is 20 rounds per second. At that rate, the belt feed mechanism must index, strip, and chamber a fresh round every 50 milliseconds. The forces involved are staggering, and the precision required for reliable feeding at that speed pushed German metallurgy and manufacturing to its absolute limits. The MG-42's rate of fire was so high that individual shots were indistinguishable to the human ear. Instead of the discrete bang-bang-bang of slower-firing weapons, the MG-42 produced a continuous ripping sound, like tearing linen, that Allied soldiers described with a variety of colorful and unprintable names. The most printable nickname was Hitler's buzzsaw. At that cyclic rate, a 250-round belt lasted approximately 12 seconds of continuous fire. 12 seconds. Then the barrel was white-hot, the belt was exhausted, and the gunner needed both a fresh belt and a fresh barrel. The MG-42's quick-change barrel system, another brilliant innovation, allowed barrel swaps in under 10 seconds. The FN MAG, designed by Fabrique Nationale of Belgium in the 1950s, refined the belt feed concept into what many consider the most reliable general-purpose machine gun ever manufactured. Adopted by over 80 countries as the MAG-58, the M240, or under various national designations, the FN MAG uses a gas-operated, open-bolt action with a robust Paul feed system that handles disintegrating M13 link belts with extraordinary reliability. The M240 variant, adopted by the United States military in the 1970s, has been praised for its ability to function in conditions that would cripple other weapons: extreme cold, fine sand, heavy mud, and prolonged firing. The Soviet approach to belt feeds emphasized simplicity and tolerance of adverse conditions. The PK machine gun, designed by Mikhail Kalashnikov in the 1960s, uses a non-disintegrating steel belt in 50-round segments. The PK's feed mechanism is notable for its generous clearances and heavy-duty construction, which makes it tolerant of dirty, corroded, or slightly out of specification ammunition. The PK and its variants have been produced in staggering numbers, equipping the armies of the Soviet Union, Russia, China, and dozens of client states. If the M240 is the refined European, the PK is the indestructible peasant who will outlast everyone at the table. The M249 squad automatic weapon, adopted by the United States in 1984, introduced a unique capability: dual feed. The M249 can feed from either a disintegrating belt or a standard STANAG box magazine. A port on the underside of the receiver accepts a standard M16/M4 magazine as an emergency backup feed source. In theory, this means a squad automatic rifleman can borrow magazines from his teammates if belt ammunition is exhausted. In practice, the M249's reliability with box magazines is significantly lower than with belts, and most experienced gunners avoid magazine feed unless absolutely desperate. The ammunition can, or ammo can, deserves mention as an integral part of the belt feed ecosystem. Belted ammunition is typically stored in metal or polymer containers that attach to the weapon or are carried separately. The standard NATO 200-round ammunition can for 7.62 millimeters belted ammunition is an olive drab metal box, roughly 10 inches long and 7 inches wide. It weighs over 13 pounds when loaded. A machine gun team typically carries 4 to 6 cans, representing 800 to 1,200 rounds. That is 40 to 60 pounds of ammunition alone, not counting the weapon, the spare barrel, tripod, and other equipment. Belt feeding is powerful, but it is not light. Aircraft machine guns and autocannons pushed belt feed technology to its absolute mechanical limits. The M61 Vulcan, a 6-barreled rotary cannon firing 20mm shells at 6,000 rounds per minute, uses a linkless feed system where rounds are stored in a helical drum and conveyed to the gun through a powered feed chute. 100 rounds per second, the tolerances and forces involved make ground-based belt feeds look leisurely by comparison. The entire ammunition handling system weighs hundreds of pounds and requires electrical power to operate. It is a magazine in the broadest sense, but it bears about as much resemblance to a pistol magazine as an aircraft carrier bears to a canoe. The helicopter door gun configuration represents another fascinating application of belt feed technology. Weapons like the M134 minigun, a 7.62mm 6-barrel rotary gun firing at 2,000 to 6,000 rounds per minute, are fed from ammunition storage systems containing 3,000 to 5,000 linked rounds. The belts are routed through flexible feed chutes from the ammunition reservoir to the weapon, and the entire system is powered by the aircraft's electrical supply. A fully loaded M134 system with 4,000 rounds of belted 7.62mm weighs approximately 350 pounds. The ammunition alone weighs more than most crew-served machine guns. Modern infantry weapons continue to rely on belt feeds for the sustained fire role. The Sig Sauer MG-338, designed for United States Special Operations Command, feeds from disintegrating belts of .338 Norma Magnum ammunition, a cartridge that offers significantly greater range and energy than the traditional 7.62mm NATO. The MG-338 represents the cutting edge of belt-fed technology. Lightweight polymer and titanium construction, advanced feed mechanisms with self-regulating gas systems, and a level of refinement that would have been unimaginable to the soldiers who crewed the first Maxim guns. The belt feed system occupies a unique position in the magazine taxonomy because, strictly speaking, it is not a magazine at all. The belt is an ammunition delivery system. It has no spring, no follower, no container walls. The rounds are held in position by the links themselves, and the weapon's own action provides the motive force to pull the belt through. But the belt serves the same fundamental function as any magazine. It stores multiple rounds and presents them sequentially to the weapon's action for chambering. By that functional definition, the belt belongs in any comprehensive discussion of ammunition feeding systems. There is an elegance to the belt feed that is easy to overlook. It is the only feeding system that scales without fundamental redesign. Want more capacity? Make the belt longer. Want less weight? Use aluminum links. Want a different caliber? Redesign the link, not the entire feeding mechanism. The belt is modular in a way that no other feeding system can match. And its open architecture means it can be inspected, repaired, and modified in the field with nothing more than a pair of pliers and some spare links. In the hierarchy of magazine designs, the belt feed is the ultimate pragmatist. As we close this chapter on belt feeds, consider the sheer volume of belted ammunition that has been manufactured since Hiram Maxim first fed a fabric belt into his prototype in 1884. Billions upon billions of linked rounds, enough brass and copper and lead and steel to fill entire warehouses. Every major military on Earth maintains vast stockpiles of belted ammunition, stored in climate-controlled bunkers, ready to be broken out and fed into weapons that have been designed, above all else, to keep firing. The belt is not glamorous, is not elegant, but it is the system that feeds the weapons that decide wars. Let's address the elephant in the room, or rather, the clip in the room. Because no discussion of firearm feeding systems is complete without examining the devices that are most often confused with magazines and most passionately argued about on the internet. Clips, specifically the in-block clip and the stripper clip. These are not magazines. They do not feed ammunition into a weapon's action. They load ammunition into a magazine. The distinction matters, and understanding it is essential to understanding how military rifles function for the better part of the century. A stripper clip, also called a charger clip, is the simpler of the two. It is a strip of stamped metal, usually spring steel, that holds a set number of cartridges by their bases. The clip is placed over the open action of a rifle. The cartridges are pushed down into the magazine with thumb pressure, and the empty clip is discarded. The clip never enters the weapon. It is a loading tool, used to quickly fill an integral or detachable box magazine. Think of it as a speed loader for a magazine, the same way a speed loader fills a revolver cylinder. The Mauser Gur 98, the defining bolt-action rifle of the late 19th and early 20th century, was designed around the 5-round stripper clip. The rifle's integral box magazine held 5 rounds of 7.92 by 57mm Mauser in a staggered column. To load, the soldier opened the bolt inserted a 5-round stripper clip into guide grooves machined into the receiver bridge and pushed the rounds down with his thumb. The clip was then discarded and the bolt closed, chambering the first round. A trained Mauser shooter could load and fire 15 aimed rounds per minute. That rate of fire defined infantry combat from 1898 to 1945. Nearly every bolt-action military rifle adopted between 1885 and 1945 used some variant of the stripper clip system. The Lee Enfield used 10-round chargers, 2 5-round clips loaded sequentially. The Mosin Nagant used 5-round clips. The Springfield 1903 used 5-round clips. The Arisaka Type 99 used 5-round clips. The Carcano used 6-round clips. The system was universal because it was effective. It allowed an integral magazine to be reloaded far more quickly than loading individual rounds, while remaining mechanically simpler and cheaper than a detachable magazine system. The in-block clip is fundamentally different. Instead of merely holding rounds for insertion into a magazine, the in-block clip itself enters the weapon and becomes part of the feeding mechanism. The clip, with its rounds still attached, is inserted as a complete unit into the weapon's internal magazine. The weapon feeds rounds directly from the clip. When the last round is fired, the clip is ejected, usually automatically. The most famous and block clip weapon is the M1 Garand, and its clip ejection produced the most recognizable sound effect in the history of small arms. The ping. That distinctive, ringing, metallic ping that the M1 Garand makes when its in-block clip is ejected after the last round is fired. It has become legendary, mythologized, the subject of more internet debate than almost any other firearms topic. The ping occurs because the clip, a stamped steel device holding 8 rounds, is ejected upward and rearward by the follower spring with considerable force once the last cartridge is stripped. The clip tumbles through the air, bounces off the operating rod or the shooter's hand, and lands on whatever surface is nearby with a bright, metallic ringing sound. The myth that has grown up around the Garand ping is that enemy soldiers could hear it and would know the American soldier's rifle was empty, prompting them to rush his position. This story has been told and retold so many times that it has achieved the status of accepted fact in popular culture. The reality is far more nuanced. On an actual battlefield with explosions, automatic weapons fire, screaming, vehicle noise, and the general cacophony of combat, the chances of hearing a single in-block clip eject from a rifle 30 or 50 meters away are essentially zero. The ping myth is entertaining. It is also almost certainly a myth. John Cantius Garand, the Canadian-born engineer who designed the M1 rifle, chose the in-block clip system for specific technical reasons. The clip simplified the weapon's internal magazine by eliminating the need for a feed lip geometry. The clip itself provided the feed geometry. This allowed the M1's action to be more compact and robust than it would have been with a detachable box magazine. The 8-round capacity was determined by the physical dimensions of the .3006 Springfield cartridge and the available space within the receiver. Garand reportedly wanted a 10-round capacity, but was constrained by the Army's dimensional requirements. The M1 Garand served as the primary American infantry rifle from 1936 to 1957, and its in-block clip system fed millions of rounds in World War II and the Korean War. General George Patton famously called it the greatest battle implement ever devised. Whether or not that assessment was accurate, the M1 was undeniably the first semi-automatic rifle issued as standard equipment to an entire army, and its in-block clip allowed soldiers to fire 8 aimed rounds as fast as they could pull the trigger. In an era when most armies still issued bolt-action rifles, that was a transformative advantage. The in-block clip had one significant tactical disadvantage that went beyond the mythical ping. Partial reloading was extremely difficult. If a soldier fired 3 rounds and wanted to top off his rifle before entering a building, he had limited options. He could not simply insert additional rounds into the clip while it was in the rifle. He had to either fire the remaining 5 rounds, eject the partially spent clip, and insert a fresh full clip, or he had to manually lock the bolt back, press the clip release, catch the ejecting clip and remaining rounds, and insert a full clip. In the heat of combat, neither option was ideal. The Italian Carcano rifles, particularly the Carcano model 1891, used a 6-round in-block clip designed by Magpul. The Carcano's clip functioned similarly to the Garand's, but for a bolt-action rifle. The clip was inserted into the internal magazine from the top, the bolt closed over it, and rounds were stripped from the clip by the bolt's forward motion. When the last round was chambered, the empty clip fell through an opening in the bottom of the magazine. The Carcano's in-block system was efficient and reliable, though the rifle itself would become infamous for entirely different reasons in November of 1963. The Magpul straight-pull rifles of the Austro-Hungarian Empire were the original and block clip weapons, dating back to the 1880s. Ferdinand Magpul, whose name keeps appearing in this documentary like a recurring character in a novel he absolutely is, designed the in-block clip as an integral part of his repeating rifle system. The Magpul clip was a simple sheet metal bracket that held 5 rounds. It inserted from the top. Rounds fed upward through the clip as the bolt was cycled, and the empty clip fell out the bottom. It was elegant, effective, and it influenced every in-block clip design that followed. There is a hybrid device that blurs the line between clip and magazine, the Breda Model 30's feed system. This Italian light machine gun used a fixed box magazine hinged to the right side of the receiver. To reload, the operator swung the magazine open like a door, placed a special 20-round charger clip into it, closed the magazine, and the weapon was ready to fire. The magazine was integral, but the ammunition came from clips. It was complicated, slow, and frequently jammed. Italian soldiers had many creative things to say about it, most of which cannot be repeated in polite company. The stripper clip has not disappeared from modern military use, despite the universal adoption of detachable magazines. NATO forces still issue stripper clips for 5.56mm ammunition, along with a small plastic device called a speed loader or spoon that attaches to the magazine and guides rounds from the clip into the magazine. Using this system, a soldier can reload a 30-round STANAG magazine from stripper clips in approximately 30 to 45 seconds, compared to 60 to 90 seconds when loading individual rounds by hand. In the field, when pre-loaded magazines are exhausted and only loose ammunition remains, the stripper clip system is invaluable. The SKS rifle, the Soviet semi-automatic carbine that preceded the AK-47, uses an integral 10-round box magazine loaded via stripper clips. The SKS's clip guide is machined into the bolt carrier, and 2 5-round clips are used to fill the magazine. The system is fast, positive, and reliable. Many SKS variants were later modified to accept detachable AK-47 magazines, but the original stripper clip-fed integral magazine remains the preferred configuration for purists and collectors. There is a satisfying mechanical precision to stripping rounds into an SKS magazine that detachable magazine users never experience. One of the most clever stripper clip adaptations came from the British during World War I. The Lee-Enfield's 10-round detachable magazine could be loaded while attached to the rifle using 2 5-round charger clips. But the British also discovered that pre-loaded magazines could be carried and swapped quickly. This gave the Lee-Enfield a dual loading capability. Quick reloads via magazine swap for the first few engagements, then fall back to charger clip loading as the supply of pre-loaded magazines was exhausted. It was a flexible system that anticipated modern tactical reload doctrine by half a century. The manufacturing economics of clips versus magazines tell an important story about military logistics. A Mauser stripper clip is a simple stamping from a single piece of spring steel. It can be manufactured in seconds at minimal cost. A detachable box magazine requires a body, a spring, a follower, a floor plate, and precise assembly. It costs 10 to 50 times more than a clip, depending on the design. For armies that needed to equip millions of soldiers, the economic argument for integral magazines loaded by clips was compelling. Clips are expendable and cheap. Magazines are reusable but expensive. The Moon clip used primarily with revolvers, deserves a brief mention in this chapter as an interesting parallel evolution. A moon clip is a thin metal disc that holds revolver cartridges by their rims, allowing the entire cylinder to be loaded or unloaded in a single motion. Full moon clips hold a complete cylinder's worth of cartridges. Half moon clips hold half. They were originally developed during World War I to allow .45 ACP cartridges, which have no rim for the revolver's extractor to grip, to be used in the Smith & Wesson model of the 1917 revolver. The moon clip solved both the loading speed problem and the extraction problem simultaneously. In competitive revolver shooting, the moon clip has transformed the revolver reload from a deliberate, multi-step process into something approaching the speed of a semi-automatic magazine change. Top competitors can empty a 6-round revolver, eject the empties with a moon clip, reload a fresh moon clip, and resume firing in under 2 seconds. The clip, in this context, has become less of a military tool and more of a competitive performance enhancer. Jerry Mikulek, widely regarded as the greatest revolver shooter who ever lived, has used moon clips to achieve rates of fire that seem to violate the laws of physics. As we conclude our exploration of clips, it is worth reflecting on their lasting impact. The stripper clip made the bolt-action rifle a viable weapon of war for 60 years. The end-block clip gave the M1 Garand the feeding speed of a semi-automatic without the complexity of a detachable magazine. The moon clip turned the revolver into a speed shooting instrument. None of these devices are magazines, but all of them are essential chapters in the story of how we learn to feed ammunition into weapons quickly and reliably. The clip may not get the glory, but without it, the magazine would have been useless. And there is something poetic about the M1 Garand's ping, mythology aside. It is a sound that marked the end of something. The last round, the empty clip, the moment of vulnerability before the reload. In a documentary about devices designed to sustain fire, the ping is a reminder that every feeding system eventually runs dry. Every magazine, every belt, every clip reaches the point where the spring has pushed its last round and the chamber echoes empty. What separates a good feeding system from a great one is not just how many rounds it holds, but how quickly and reliably the shooter can transition from empty to full again. The double-stack box magazine, as we discussed, was a brilliant solution to capacity. 2 columns of ammunition interleaved in a single container, roughly doubling capacity compared to a single stack while adding only moderate width. But eventually, even that was not enough. Military planners and shooters began asking, what if we added more columns? What if instead of 2 stacks we used 4? The quad-stack magazine was born from this ambition, and it pushed the box magazine concept into territory that its original designers never imagined. The basic engineering challenge of a quad stack is managing the transition from 4 columns to the single feed position at the top of the magazine. In a standard double stack magazine, 2 columns converge to 1 through a carefully angled taper in the magazine body. In a quad stack, 4 columns must converge to 2 and then to 1, or 4 columns must converge directly to 1 through a more complex geometry. Each transition point is an opportunity for ammunition to jam, tilt, or stack up. The more transitions, the more potential failure points. The Soviet Union was among the first to deploy a quad-stack magazine in significant numbers. The 6L-31 magazine, designed for the RPK-74 light machine gun in 5.45 by 39 millimeters, holds 45 rounds in a 4-column configuration. From the outside, it looks like a slightly wider and longer standard AK-74 magazine. Internally, it is a 4-column design that tapers to a double stack at the feed lips. The 6L-31 was issued to RPK-74 gunners as a lightweight alternative to the larger drum magazine, offering 50% more capacity than the standard 30-round box without the weight and complexity of a drum. The 6L-31 earned a mixed reputation in Soviet and Russian service. When properly loaded and maintained, it functioned adequately, but the 4-to-2 column transition was sensitive to ammunition condition and spring tension. Dirty or slightly corroded rounds could cause jams at the convergence point. and the wider body made the magazine slightly more difficult to insert into and remove from the magazine well, particularly when wearing heavy winter gloves. Soviet soldiers, never known for their delicacy with equipment, sometimes forced the magazines into place, bending the feed lips and creating reliability problems that were blamed on the design rather than the handling. The term casket magazine is sometimes used interchangeably with quad stack, though it properly refers to a specific subset of high-capacity box magazines with a roughly rectangular cross-section. The name comes from a magazine's shape, wider and flatter than a standard double stack, resembling a small coffin or casket when viewed in cross-section. The distinction between casket and quad stack is largely semantic. Both involve more than 2 columns of ammunition in a box format. But the term casket has stuck in the firearms community, particularly for Soviet and Russian designs. Surefire, the American company best known for its tactical flashlights, entered the magazine market with the MAG 560 and MAG 500 60-round and 100-round quad-stack magazine for the AR-15/M4 platform. The MAG 560 uses a 4-column body that tapers to a double feed at the top, fitting a standard STANAG magazine well. The MAG 500 extends the concept to 100 rounds, producing a magazine that is roughly the same width as a standard 30-round magazine, but significantly longer and housing 4 columns of 5.56mm ammunition. The Surefire 100-round magazine was adopted by United States Special Operations Command for use with the M4A1 carbine in the squad automatic rifle roll. The idea was elegant. Instead of carrying a dedicated belt-fed squad automatic weapon, a rifleman could mount a 100-round Surefire magazine on a standard M4 and provide suppressive fire. The weapon remained light, familiar, and capable of using standard 30-round magazines when a 100-round magazine was empty. In theory, it was the best of both worlds. In practice, the results were complicated. Reliability was the Surefire's persistent challenge. The 4-column to single-feed transition, stretched over 100 rounds, created a long internal feed path with multiple convergence points. If a single round tilted or caught at any convergence, the entire magazine could jam. Early production Surefire magazines had failure rates that made experienced soldiers uncomfortable. Later revisions improved reliability significantly, but the 100-round Surefire never achieved the near-perfect feeding reliability of a standard 30-round PMAG. When you are staking your life on a magazine feeding correctly, significantly improved is not the same as flawless. The 60-round Surefire, by contrast, found a more comfortable niche. With only 4 columns converging over 60 rounds, the internal feed path was shorter and less prone to misalignment. The 60-round magazine fit a standard STANAG well, extended roughly the same distance below the weapon as a standard magazine, and provided double the capacity. It was heavier than 2 30-round magazines, but offered the advantage of continuous fire without a reload. For vehicle crews, support personnel, and anyone who valued sustained fire from a standard rifle, the 60-round quad stack was a legitimate tactical option. Magpul's approach to extended capacity was more conservative and, arguably, more successful. The Magpul PMAG 40, released in 2015, simply extended the proven double-stack PMAG design from 30 rounds to 40. No quad-stack complexity. No multiple convergence points. Just 10 more rounds in a slightly longer version of the most reliable polymer magazine on the market. It was an unglamorous solution. It lacked the eye-catching capacity of a 60 or 100-round magazine. But it worked with the same monotonous reliability that had made the 30-round PMAG the industry standard. The PMAG 40 illustrates an important principle in magazine design. Incremental improvement often outperforms radical innovation. Adding 10 rounds to a proven 30-round design is less exciting than quadrupling capacity with a novel 4-column architecture. But the PMAG 40 feeds with the same reliability as its 30-round sibling because it uses the same internal geometry, the same follower, and the same spring type. The only trade-off is length. A PMAG 40 extends about an inch further below the weapon than a PMAG 30. For most shooters, that is an acceptable compromise for an extra 10 rounds of flawless feeding. The coffin magazine is another high-capacity variant that deserves distinct attention. While the term is sometimes used loosely for any oversized box magazine, it properly refers to magazines with a wide, flat cross-section that holds rounds in two side-by-side double-stack columns. Think of it as two double-stack magazines fused together in a single body. The result is a 4-column feed system where each pair of columns has its own convergence to a feed position and the two feed positions alternate delivery to the weapon's action. It is the widest of all box magazine configurations. The Israeli IWI Negev light machine gun uses a variant of the coffin magazine concept with its proprietary 150-round and 200-round assault magazines. These are wide, flat, semi-rigid containers that hold belted ammunition in a coiled or folded configuration. Technically, they are belt containers rather than true magazines, but their form factor and the way they attach to the weapon make them functionally similar to oversized coffin magazines. They provide the capacity of a belt-fed system with the attachment simplicity of a box magazine. The Negev can also feed from standard STANAG magazines, giving it extraordinary logistical flexibility. The KCI Korean-made 50-round drum and 33-round extended magazine for the Glock pistol brought high-capacity box magazine concepts to the handgun market. The 33-round Glock magazine is essentially a standard double-stack Glock 17 magazine extended to grotesque proportions. It extends roughly 8 inches below the grip and holds more than twice the ammunition of a standard 17-round magazine. It looks absurd. It handles poorly, and it has become one of the most popular aftermarket pistol accessories in America, because apparently the desire for more rounds is a universal human impulse that transcends all considerations of aesthetics and practicality. There are engineering reasons why quad-stack designs for pistol cartridges are particularly challenging. Pistol cartridges like the 9mm Parabellum are shorter and wider relative to their length than rifle cartridges. This means the columns in a quad-stack pistol magazine are proportionally wider, making the overall magazine body too thick to fit inside a standard pistol grip. Most attempts at quad-stack pistol magazines have resulted in devices so wide that they require a completely redesigned grip frame, negating the compatibility advantage that makes extended magazines attractive in the first place. The Kel-Tec PMR 30 pistol sidestepped the quad-stack problem by using the small, low-pressure .22 Winchester Magnum rimfire cartridge. The PMR 30's 30-round flush-fit magazine is a double-stack design that takes advantage of the tiny .22 WMR cartridge's diminutive dimensions. 30 rounds of .22 WMR fit in a grip that is only slightly wider than a standard 9mm double-stack. It demonstrates that capacity is not just about magazine engineering. It is about the relationship between magazine engineering and cartridge dimensions. Smaller rounds mean more rounds in the same space. That is not insight. That is arithmetic. But it is arithmetic that matters. The FN P90 personal defense weapon uses what might be described as the most unconventional box magazine in service anywhere in the world. Its 50-round magazine sits on top of the weapon, running parallel to the barrel. Rounds are stored perpendicular to the bore axis and are rotated 90 degrees as they enter the feed throat. The magazine is transparent, allowing visual round counting, and its unique geometry keeps the weapon compact despite the high capacity. The P90's magazine is technically a double-stack box, but its orientation and feed mechanism make it unlike any other box magazine in existence. The P90 magazine deserves closer examination because it represents a fundamentally different approach to the capacity problem. Rather than making the magazine wider, quad-stack, or longer, extended, FN's designers made it horizontal. The 50-round magazine lies flat on top of the weapon, distributing its length along the barrel rather than extending below the weapon. Rounds are arranged nose down in two parallel rows. As the internal mechanism advances rounds toward the feed point, each round passes through a spiral ramp that rotates at 90 degrees, aligning the bullet with the bore. It is a mechanical ballet, and it works with remarkable reliability for something so unconventional. The P90 magazine was designed by Hervé Delvaux, an FN engineer who reportedly spent years refining the spiral rotation mechanism. The challenge was ensuring that each round completed its 90-degree rotation consistently, regardless of whether the magazine was full or nearly empty, regardless of temperature, regardless of orientation. A round that fails to rotate fully will jam at the feed throat with absolute certainty. Delvaux's solution used a combination of magazine wall geometry and the round's own center of gravity to guide the rotation passively, without springs or cams at the rotation point. It is one of the most elegant pieces of ammunition feed engineering in existence. The quad stack, the casket, the coffin, and the horizontal rotary feed of the P90 all represent attempts to push the box magazine beyond its original design envelope. Some have succeeded, some have struggled. All have taught designers valuable lessons about the relationship between capacity, complexity, and reliability. The common thread is clear. Adding capacity to a box magazine always adds complexity, and complexity is the enemy of reliability. The art of magazine design is finding the sweet spot where capacity is maximized and complexity has not yet crossed the threshold into unreliability. That sweet spot, as the market has determined, appears to be somewhere around 30 to 40 rounds for a rifle and 17 to 21 rounds for a pistol. These are the capacities that standard double-stack magazines can achieve with high reliability. Going beyond them requires either quad-stack complexity, drum mechanisms, or unconventional geometries like the P90's horizontal layout, all of which work to varying degrees, but none of which match the simple, proven reliability of a standard double-stack box. The box magazine's greatest limitation, its finite capacity and a practical size, is also a reminder that engineering is always about trade-offs. In an era dominated by detachable magazines, there is something almost nostalgic about the integral magazine, a weapon where the ammunition storage is not a separate component but a permanent part of the structure. You cannot drop it. You cannot lose it. You cannot forget to bring it. The integral magazine is always there, built into the receiver or the stock, waiting to be loaded. It is the original magazine concept, predating the detachable box by decades, and it carries with it a philosophical simplicity that modern firearms have largely abandoned in favor of the quick reload. Every bolt-action military rifle we discussed in the Clips chapter, the Mauser, the Mosin-Nagant, the Springfield 1903, the Arisaka, use an integral box magazine as its standard configuration. These magazines were machined or formed as part of the receiver assembly. They could be disassembled for cleaning by removing a floor plate, but they were not intended to be removed and replaced during firing. Ammunition went in through the top via stripper clips. Spent cases came out through the ejection port, and the magazine itself stayed put, a permanent resident of the weapon's architecture. The integral magazine's greatest advantage was also its greatest limitation. It could not be pre-loaded away from the weapon. With a detachable magazine, a soldier could carry multiple loaded magazines and swap them in seconds. With an integral magazine, the only way to reload was to feed rounds into the weapon itself, either individually or via clips. This meant that reload speed was limited by the speed of clip loading, not by the speed of magazine insertion. For a bolt-action rifle fired at 15 rounds per minute, this was acceptable. For a semi-automatic or automatic weapon, it was crippling. The SKS rifle, adopted by the Soviet Union in 1945, represents the last major military rifle designed around an integral magazine. Its 10-round internal box magazine, loaded by two 5-round stripper clips, was adequate for the semi-automatic carbine role the SKS was designed to fill. But within 2 years of its adoption, the AK-47 arrived with its 30-round detachable magazine, and the SKS was immediately rendered obsolete for frontline service. The contrast was stark. 10 rounds with a slow clip reload versus 30 rounds with a fast magazine swap. The detachable magazine had won the argument conclusively. Yet the SKS did not disappear. It became one of the most widely distributed firearms in history, produced by the millions in the Soviet Union, China, Yugoslavia, Romania, East Germany, Albania, North Korea, and Vietnam. Chinese Type 56 carbines, the most numerous SKS variant, were exported to revolutionary movements and allied governments across Africa, Asia, and Latin America. The integral magazine, with its 10-round capacity, was considered adequate for guerrilla fighters and militia forces who were unlikely to encounter opponents with 30-round detachable magazines. In the economics of insurgency, the SKS was good enough. Hunting rifles have maintained the integral magazine tradition more consistently than any other firearms category. The Remington Model 700, the most popular bolt-action hunting rifle in America, uses a 3 to 5 round integral box magazine, depending on caliber. The Winchester Model 70 uses a similar system. The Ruger American, the Savage Axis, the Tikka T3. Virtually every modern bolt-action hunting rifle uses an integral magazine, often with the option of a detachable magazine conversion kit. For a hunting rifle, where the shooter may fire 1 to 3 rounds in an entire day's outing, the capacity limitation of an integral magazine is completely irrelevant. The integral magazine in a hunting context offers advantages that are often overlooked. It creates a slimmer, lighter receiver with no protruding magazine body to snag on brush, clothing, or scabbards. It eliminates the possibility of a magazine release being accidentally activated, dumping the magazine in the field. And it reduces the total cost of the weapon by removing the need for a separate detachable magazine, which can cost $20 to $50 for a precision bolt action. For a hunter who needs 3 rounds of .308 Winchester, paying extra for a detachable magazine system is like paying extra for cup holders on a bicycle. The Stare Scout rifle, designed by legendary firearms instructor Jeff Cooper, represents an interesting philosophical statement about integral versus detachable magazines. Cooper's original Scout rifle concept specified a detachable box magazine that held 5 rounds, emphasizing that a rifleman who needed more than 5 rounds should be better at shooting, not carrying more ammunition. The production Stare Scout offered both a detachable 5-round magazine and a 10-round option, but Cooper maintained that 5 rounds was sufficient for any competent marksman. It was less a magazine specification and more a value judgment about marksmanship and self-reliance. Shotguns with integral magazines extend beyond the tubular type we discussed earlier. Some specialty shotguns, particularly single-shot and double-barrel designs, have no magazine at all. A single-shot break-action shotgun holds 1 shell in the chamber. A side-by-side double-barrel holds 2. An over-under holds 2. These weapons have 0 magazine capacity. They fire only what is directly chambered. In a documentary about magazines, these guns represent the null case. Weapons that exist entirely outside the magazine concept. They're loaded, fired, opened, reloaded, and fired again, 1 or 2 rounds at a time, in a rhythm unchanged since the flintlock era. And yet, the single shot and double barrel remain enormously popular worldwide. In many countries, particularly in Europe, Africa, and parts of Asia, the single shot break action is the most common civilian firearm. It is the cheapest gun to manufacture, the simplest to maintain, the safest to store. And for a farmer protecting livestock from predators or a subsistence hunter taking 1 careful shot at a deer, a single shot with no magazine is all that is needed. The magazine, for all its importance in warfare, is not a universal requirement for a useful firearm. The concept of a hybrid integral and detachable system appeared in several experimental designs over the years. The Browning BLR lever-action rifle, for example, uses a detachable box magazine, but is designed so that the magazine can be topped off through the action without removing it. Load individual rounds through the ejection port, or swap the entire magazine for a fresh one. This dual capability gives the BLR the best of both worlds. the quick reload of a detachable system with the top-off capability of an integral. It is an underappreciated design that deserves more recognition than it typically receives. The Krag-Jorgensen rifle, adopted by the United States military in 1892, used one of the most unusual integral magazine designs ever fielded. Its 5-round magazine was a capsule-shaped box mounted horizontally on the right side of the receiver, with a hinged loading gate that swung open to allow rounds to be dropped in. A spring plate inside the magazine pushed rounds laterally through a feed channel that curved underneath the bolt and up into the feed position. It was, mechanically speaking, a horizontal gravity and spring-fed integral box. It was also quite slow to load compared to a Mauser with stripper clips, which became painfully apparent during the Spanish-American War. The Krag side loading gate had one advantage that its critics often overlooked. It could be loaded one round at a time without opening the bolt. A soldier could keep his weapon ready to fire while simultaneously feeding rounds into the magazine through the gate. This was impossible with a Mauser or Springfield, which required the bolt to be opened for clip loading. In theory, this meant a Krag shooter was never truly defenseless during reloading. In practice, the speed advantage of the Mauser's stripper clip loading was so overwhelming that the United States abandoned the Krag for the Springfield 1903 within a decade. Modern legal compliance has created an entirely new category of pseudo-integral magazines. In jurisdictions that ban detachable magazines in semi-automatic rifles, notably California and New York, manufacturers have developed fixed magazine systems that require the weapon's action to be opened before the magazine can be removed. The magazine is technically detachable, but is locked in place by a mechanism that can only be disengaged when the upper and lower receivers are separated. This allows the magazine to be removed and loaded externally, but prevents the rapid magazine swap that characterizes standard detachable magazine weapons. Devices like the Hera Arms Comp Mag and the Mean Arms MA loader attempt to replicate the loading speed of a detachable magazine within the legal framework of a fixed magazine. The Comp Mag is a permanently attached 10-round magazine that can be loaded through the ejection port using stripper clips. The MA loader is a device that interfaces with the ejection port and allows 10 rounds to be loaded into a fixed magazine in a single push. Both are inventive responses to legal constraints, and both demonstrate that magazine design is shaped not only by ballistic requirements, but by political realities. The AR maglock system, popular in California, uses a pin that connects the magazine release to the rear takedown pin. When the takedown pin is pushed, the upper receiver pivots slightly, unlocking the magazine release and allowing the magazine to be dropped. The action must be partially opened before the magazine can be removed, which satisfies the legal definition of a fixed magazine while adding only a fraction of a second to the reload process. It is a masterpiece of compliance engineering, designed not to improve the weapon's performance, but to navigate the maze of firearms regulation while losing as little practical capability as possible. These compliance-driven magazine designs represent a fascinating chapter in firearms history that is still being written. They are shaped by legislation rather than combat requirements. Their engineering goals are legal rather than tactical, and they evolve in real time as laws are enacted, challenged, revised, and reinterpreted. The fixed magazine, in its modern compliance form, is neither the integral magazine of the bolt-action era nor the detachable magazine of the modern military rifle. It is something entirely new, a magazine designed by lawyers as much as by engineers. As we leave the world of integral and fixed magazines, let's take a moment to appreciate what they represent in a broader story. The integral magazine was the beginning, the first successful attempt to give a firearm more than one shot without manually loading each round. It was crude, limited, and eventually eclipsed by the detachable magazine. But it was the foundation upon which everything else was built. Every box magazine, every drum, every belt feed exists because someone, somewhere, first had the idea of storing ammunition inside the weapon and feeding it to the chamber mechanically. And the integral magazine never truly went away. It adapted. It found niches where its simplicity was valued over the detachable magazine speed. It remained the standard for hunting rifles, rimfire target rifles, and shotguns. And in the strange modern world of compliance engineering, it has been reborn in hybrid forms that its original designers would find both ingenious and utterly baffling. The magazine built into the gun was the first answer to the question of sustained fire. It was not the best answer, but it was the one that started the conversation. Until now, we have discussed magazines purely as engineering objects, mechanical devices defined by springs, followers, feed lips, and cartridge geometry. But in the late 20th century, the gun magazine became something else entirely, a political object, a symbol, a legislative target. The number of rounds a magazine could hold became one of the most fiercely debated questions in American politics, fought over in courtrooms, state legislatures, and the halls of Congress with an intensity usually reserved for matters of war and peace. Because in America, magazines are matters of war and peace. The story begins in 1989 when a gunman used a semi-automatic rifle with detachable magazines to attack an elementary school in Stockton, California. The shooting killed 5 children and wounded 32 others. The weapon used 30 and 75 round magazines. The public outcry was immediate and profound, and it set in motion a legislative chain reaction that would culminate in the most significant firearms regulation since the National Firearms Act of 1934. California responded first, enacting the Roberti-Roos Assault Weapons Control Act of 1989, which banned the sale of specific semi-automatic firearms by name. But the legislation quickly encountered the reality of firearms design. Manufacturers simply modified their weapons slightly, changed a model name, and continued selling functionally identical products. The named ban approach was, critics argued, like trying to ban specific breeds of dog by listing their names while ignoring what makes a dog dangerous. The legislature would eventually shift its focus from the weapon to the magazine. The federal assault weapons ban, signed into law by President Bill Clinton on September 13, 1994, included a provision that would reshape the American firearms industry for a decade, a ban on the manufacture and sale of new magazines holding more than 10 rounds. Existing magazines were grandfathered, meaning millions of pre-ban magazines could still be legally owned, bought, and sold. But no new magazines exceeding 10 rounds could be manufactured for civilian sale. The 10-round limit was somewhat arbitrary, chosen as a round number that was lower than the 13 to 17 rounds typical of full-size pistol magazines. The ban's impact on magazine design was immediate and profound. Every major firearms manufacturer had to redesign their magazines to comply with the 10-round limit. Double-stack pistols received single-stack magazines. Standard capacity 30-round rifle magazines were replaced with truncated 10-round versions. And a massive secondary market developed for pre-ban magazines, which were exempt from the restriction and quickly appreciated in value. A pre-ban Glock 17 magazine that had cost $15 new was suddenly worth $60 to $80 on the secondary market. Supply and demand, as always, proved more powerful than legislation. The 10-round pistol magazines created during the ban era were a study in compromise engineering. The Glock 17, designed to hold 17 rounds in its double-stack magazine, received a restricted magazine that blocked the internal space to prevent loading more than 10 rounds. The same spring, the same follower, the same body, just with a dimple or a block inside that stopped the stack at 10. Some manufacturers created entirely new single-stack 10-round magazines, while others simply modified their existing designs. The result was a patchwork of compliant solutions, each one a small monument to regulatory creativity. For rifle magazines, the impact was even more visible. The standard 30-round AR-15/M4 magazine was replaced by a 10-round magazine that looked comically small attached to a full-size rifle. The proportions were wrong. A weapon designed around a 30-round magazine looked incomplete with 10 rounds dangling from its magazine well. Aesthetics aside, the reduced capacity changed shooting habits, competition formats, and training doctrine for an entire generation of civilian shooters who came of age during the ban era and knew nothing else. The federal assault weapons ban included a sunset clause. It would expire automatically after 10 years unless Congress voted to renew it. On September 13, 2004, the ban expired. Congress did not renew it. The following day, standard capacity magazines were once again legal to manufacture and sell nationwide. The firearms industry responded with an explosion of magazine production that flooded the market with 30-round rifle magazines and 17-plus round pistol magazines. Prices dropped, availability surged, and the 10-round magazine, for states without their own restrictions, became a niche product rather than the standard. But the ban's expiration was not the end of the story. It was the beginning of a new chapter. Several states, including California, New York, New Jersey, Connecticut, Maryland, Massachusetts, Colorado, Vermont, and the District of Columbia, enacted their own magazine capacity restrictions. These state laws varied in their specifics. Some limited magazines to 10 rounds, others to 15, and the definitions of what constituted a prohibited magazine differed from state to state. The result was a confusing patchwork of regulations that turned magazine capacity into a geography-dependent legality. California's magazine capacity law became the most legally contested. In the landmark case Duncan versus Bonta, federal judge Roger Benitez struck down California's 10-round magazine limit in 2019, ruling that it violated the Second Amendment. His opinion included a memorable passage comparing a 10-round magazine to a Swiss Army knife, arguing that both were common, lawful items with legitimate purposes. The decision was stayed pending appeal, and as of the time of this writing, the case has made its way through the appellate system in a legal journey that has lasted years and generated thousands of pages of legal argumentation. The Supreme Court's 2022 decision in New York State Rifle and Pistol Association versus Bruin introduced a new framework for evaluating firearms regulations, requiring that restrictions be consistent with the historical tradition of firearms regulation. This framework has been applied to magazine capacity challenges across the country, with courts examining whether ammunition capacity limits have historical precedent. The results have been inconsistent, with different courts reaching different conclusions about the historical basis for capacity restrictions. The legal landscape remains, as of today, deeply fractured. The empirical debate over whether magazine capacity limits reduce crime has generated an enormous body of research with frustratingly inconclusive results. Studies by the RAND Corporation, Johns Hopkins Bloomberg School of Public Health, and numerous academic institutions have examined the relationship between magazine capacity restrictions and various measures of gun violence. Some studies found modest associations between capacity limits and reduced mass shooting casualties. Others found no statistically significant effect. The data, like the politics, is contested at every level. One argument advanced by proponents of capacity limits is the forced pause theory. When a shooter must stop to reload, that pause creates an opportunity for bystanders to flee or for others to intervene. The 2011 Tucson shooting is often cited. The gunman was tackled while attempting to reload after emptying a 33-round Glock magazine. The argument is that a 10-round limit would have forced an earlier reload, creating an earlier opportunity for intervention. Critics counter that a practiced shooter can swap magazines in under 2 seconds and that a determined attacker will simply carry more magazines. The compliance magazine industry that has grown around capacity restrictions is worth examining as a distinct economic phenomenon. Companies like HexMag, Mean Arms, and Cross Industries have developed products specifically designed to navigate the legal landscape. Riveted magazines that physically prevent loading more than 10 rounds. Blocked magazines with internal spacers. Compliance kits that convert standard capacity magazines to 10-round limits. An entire sub-industry exists solely because of legislation, creating products that serve no tactical or sporting purpose beyond satisfying the requirements of the law. The magazine body kit phenomenon is particularly interesting. A standard 30-round PMAG body can be converted to a compliant 10-round configuration by installing an internal block and riveting the body to prevent disassembly. The resulting product is physically identical to a standard PMAG from the outside, but holds only 10 rounds. Some manufacturers produce dedicated 10-round mags with shorter bodies, while others produce 30-round bodies with internal restrictions. The distinction matters legally in some jurisdictions, where possessing a magazine body capable of holding more than 10 rounds, even if blocked, may itself be a violation. The cultural dimension of the magazine capacity debate cannot be separated from its legal dimension. For many gun owners, magazine capacity restrictions are perceived as symbolic attacks on firearms ownership itself, incremental steps toward broader prohibitions. For many advocates of gun violence prevention, capacity limits are modest, common-sense measures that balance individual rights with public safety. Both sides hold their positions with genuine conviction, and the debate shows no signs of resolution. The magazine, an engineering object designed to store and feed ammunition, has become one of the most politically charged consumer products in America. International magazine restrictions present a different picture. In most European countries, civilian magazine capacity is strictly limited, typically to 10 rounds for rifles and to the magazine's standard capacity for handguns, which are themselves heavily restricted. In Canada, rifle magazines are limited to 5 rounds and pistol magazines to 10. In Australia, magazine restrictions are part of a comprehensive firearms control regime enacted after the 1996 Port Arthur massacre. In much of the world, the idea of a civilian owning a 30-round rifle magazine is not just unusual, it is unthinkable. The 3D printing revolution has introduced a new variable into the magazine capacity debate. Designs for printable standard capacity magazines, including functional 30-round AR-15 magazines, have been freely available online since the early 2010s. The Menendez magazine, named after the designer who published it, is a 3D printable 30-round AR-15 magazine that can be produced on a consumer-grade FDM printer for approximately $2 in materials. The existence of printable magazines has raised profound questions about the enforceability of capacity restrictions in an era where manufacturing capability is increasingly decentralized. The legal, political, and cultural battles over magazine capacity are far from over. New legislation is proposed regularly at both state and federal levels. Court challenges work their way through the judicial system, and the firearms industry continues to innovate around, within, and sometimes in defiance of regulatory constraints. The magazine, that simple box with a spring, has become a contested object at the intersection of constitutional law, public health policy, engineering, and cultural identity. It is a lot of weight for a few ounces of steel and polymer to carry. What the capacity debate reveals, perhaps more than anything, is how central the magazine has become to the firearms ecosystem. A gun without a magazine is a single shot. A magazine transforms it into something else entirely, a repeating weapon with sustained fire capability. The capacity of that magazine determines how long the weapon can fire before pausing. And how long a weapon can fire before pausing is, depending on your perspective, either a critical feature of personal defense or a critical factor in the lethality of mass violence. The same object, two irreconcilable interpretations, one small box with an enormous shadow. As we close this chapter, let us note that the politics of magazine capacity are, in a very real sense, a testament to the magazine's importance. No one passes laws about trivial objects. No one litigates to the Supreme Court over devices that do not matter. The fact that the magazine has become a political battleground, contested with the same intensity as healthcare and taxation and civil rights, tells you everything you need to know about its significance. The magazine matters, and because it matters, it is fought over. That is the nature of things that matter. Pick up a magazine, any magazine. Feel its weight. Run your thumb across its surface. Is it cold to the touch, with a slightly oily sheen? That is steel. Is it lighter, with a matte gray finish that warms quickly in your hand? Aluminum. Is it lighter still, with a subtle texture and a faint chemical smell when new? Polymer. The material a magazine is made from is not a trivial detail. It determines the magazine's weight, its durability, its cost, its temperature behavior, and ultimately, its reliability. The material is the foundation upon which every other design decision rests. Steel was the original magazine material, and it dominated for nearly a century. The earliest detachable box magazines, from James Paris Lee's 1879 design through the magazines of both world wars, were constructed from stamped or drawn steel. The process was straightforward. Take a flat sheet of carbon steel, stamp it into a box shape using a progressive die, spot weld or seam weld the joints, apply a protective finish, and install the internal components. Steel magazines were heavy, but they were strong, cheap to produce in enormous quantities, and tolerant of the rough handling that military service demanded. The AK-47 magazine is the gold standard of stamped steel magazine construction. Formed from 1mm steel sheet, seam welded along the spine, and finished with a phosphate or paint coating, the AK magazine is brutally robust. It can be dropped on concrete, run over by vehicles buried in sand, submerged in water, and frozen solid, and it will still function. The generous internal clearances that Kalashnikov built into the AK platform extend to the magazine. Rounds have room to shift and settle, reducing the chance of binding even when the magazine is filthy. It is not elegant, it is not light, but it works in conditions that would destroy lesser designs. The weight penalty of steel is significant. A standard 30-round AK-47 steel magazine weighs approximately 330 grams empty. A soldier carrying 6 loaded magazines adds roughly 3.5 kilograms to his combat load just in magazines and ammunition. Multiply that across a platoon, a company, a division, and the aggregate weight of steel magazines becomes a logistical consideration that affects everything from vehicle loading to helicopter lift capacity. Armies have spent billions of dollars on lighter materials for the sole purpose of shaving grams off individual equipment items. The magazine was an obvious target. Aluminum entered the magazine world in the late 1950s with the development of the M16 rifle. The original M16 magazines were fabricated from 6061 T6 aluminum alloy, an aerospace-grade material that offered roughly 1/3 the weight of steel with adequate strength for the relatively low-pressure, small-caliber 5.56 mm cartridge. An empty 30-round aluminum STANAG magazine weighs approximately 110 grams, less than a third of the equivalent steel AK magazine. The weight savings were transformative. A soldier could carry the same number of magazines for a fraction of the weight penalty. But aluminum had weaknesses that steel did not. Aluminum is softer. It dents more easily. And critically, the feed lips of an aluminum magazine, the precisely angled metal tabs at the top that control how rounds are presented to the bolt, could be bent or deformed by relatively modest impacts. A steel magazine dropped on a rock would bounce. An aluminum magazine dropped on the same rock might land on its feed lips and bend them just enough to cause feeding failures. The feed lips are the most critical dimension on any box magazine, and aluminum's susceptibility to deformation at this crucial point was a persistent concern. The solution, when it finally arrived, came from an unexpected direction: plastic, or more precisely, glass-reinforced nylon polymer. Gaston Glock was among the first to prove that polymer could serve as a primary structural material for firearms when he introduced the Glock 17 in 1982. The Glock's magazine, molded from the same polymer as the frame, demonstrated that a properly engineered polymer magazine could match or exceed the reliability of steel and aluminum designs while offering significant weight and cost advantages. The polymer revolution in magazine design accelerated dramatically with Magpul's introduction of the PMAG in 2007. The PMAG was not the first polymer rifle magazine, The mold and Orlite had produced polymer magazines in the 1980s and 1990s, but it was the first to achieve widespread acceptance based on proven reliability rather than weight savings alone. Magpul's proprietary polymer blend was engineered specifically for magazine use. Flexible enough to absorb impacts without cracking, rigid enough to maintain feed lip geometry under load, and resistant to the chemicals, solvents, and temperature extremes that military service demanded. One of the most important properties of Magpul's polymer is its behavior at extreme temperatures. At -60 degrees Fahrenheit, many polymers become brittle and can crack or shatter on impact. At 160 degrees Fahrenheit, some polymers soften and deform under sustained load. Magpul tested their polymer across a temperature range that exceeded the operational requirements of every major military on Earth, from Arctic operations to desert deployments. The PMAG passed. It functioned reliably at temperatures that would make a human being either hypothermic or heat-stroked. The magazine, evidently, is tougher than we are. The feed lip debate, steel versus polymer, remains one of the most contentious topics in the magazine world. Steel feed lips, as found on aluminum STANAG magazines and the Lancer L5, are harder and more resistant to deformation over time. They maintain their geometry almost indefinitely, even after thousands of loading and unloading cycles. Polymer feed lips, as found on the PMAG, are softer and can theoretically deform or develop feed lip spread after extended use. Magpul addressed this concern by including a dust cover with every PMAG that snaps over the feed lips and prevents them from spreading when the magazine is stored loaded. In practice, the feed lip debate has been largely settled by millions of rounds fired through millions of PMAGs worldwide. Feed lip failures in PMAGs are exceedingly rare when the magazines are used within their design life. Magpul recommends replacing PMAGs after a certain number of loading cycles, treating them as consumable items rather than permanent equipment. This is a philosophical shift from the steel and aluminum era, where magazines were expected to last indefinitely. The polymer magazine is lighter, cheaper, and arguably more reliable, but it is designed to be replaced rather than maintained forever. The Lancer L5 Advanced Warfighter magazine, as we touched on briefly in an earlier chapter, represents the hybrid approach, a translucent polymer body with hardened steel feed lips. This gives the magazine the impact resistance and weight savings of polymer construction with the feed lip durability of steel. The translucent body allows visual round counting. The steel lips resist deformation over tens of thousands of cycles. It is the most expensive common AR-15 magazine on the market, but for users who demand both durability and visibility, the premium is justified. Bakelite, the vintage polymer used for Soviet AK-74 magazines in the 1970s and 1980s, deserves special mention as an early experiment in polymer magazine construction. The distinctive orange-brown Bakelite AK-74 magazine was made from AG4S fiberglass reinforced phenolic resin, a material that was lightweight and rigid but somewhat brittle compared to modern polymers. Bakelite magazines have become highly sought after collector's items, commanding prices of $50 to $100 each on the surplus market. Their appeal is partly functional and partly aesthetic. The warm, organic look of Bakelite stands in stark contrast to the utilitarian black of modern polymer magazines. Modern Russian military magazines have transitioned to a dark plum or black polymer that is significantly more durable than the original Bakelite. The current production AK-12 magazines use a glass-reinforced polymer that is functionally equivalent to Magpul's PMAG material, though with different proprietary additives. The Russians, who pioneered polymer magazine construction with Bakelite decades before Magpul existed, eventually arrived at the same material science conclusions as the rest of the world. Glass-reinforced nylon is the optimal magazine polymer. They just took a more circuitous route to get there. Titanium has appeared in a handful of ultra-premium magazine designs, primarily aimed at competitive shooters and military special operations units willing to pay extraordinary prices for marginal weight savings. A titanium magazine body can weigh 30 to 40% less than aluminum while matching or exceeding steel strength. The problem is cost. Titanium is extraordinarily difficult to machine, cannot be easily stamped or formed like steel or aluminum, and the raw material itself costs 10 to 20 times more than comparable alloys. A titanium magazine can cost $300 or more. For most users, the savings of a few grams does not justify the price of a decent handgun. Carbon fiber reinforced polymer is another exotic material that has been explored for magazine construction, though primarily in prototype and limited production. Carbon fiber offers an exceptional strength-to-weight ratio, but it is anisotropic, meaning its strength varies depending on the direction of a load. A carbon fiber magazine body could be extremely strong in one axis and fragile in another, which creates design challenges for a component that experiences forces in multiple directions during feeding and handling. To date, no major manufacturer has released a production carbon fiber magazine, though several prototypes have been demonstrated at industry trade shows. 3D printed magazines, produced on consumer-grade FDM and SLA printers, have opened an entirely new front in the materials war. The most common printing material is PLA+, a polylactic acid variant that offers decent layer adhesion and moderate impact resistance. More advanced users print in nylon, PEG, or polycarbonate, which offer significantly better mechanical properties. A properly printed nylon magazine, with appropriate infill density and layer orientation, can approach the performance of injection-molded polymer magazines at a fraction of the cost. The democratization of manufacturing has reached the magazine. The durability of 3D printed magazines varies enormously depending on the material, the printer's settings, and the design. Feed lips are the critical failure point, as they bear the highest loads and require the most precise geometry. Some printed magazine designs reinforce the feed lip area with metal inserts or additional material thickness. Others rely entirely on the printed polymer and accept a shorter service life. The Menendez magazine, one of the most widely distributed open-source AR-15 magazine designs, has been documented to function reliably for several hundred rounds before feed lip degradation becomes noticeable. Several hundred rounds is not military grade, but it is enough to prove the concept. The material a magazine is made from interacts with its environment in ways that are not always obvious. Steel magazines in humid climates rust without constant maintenance. Aluminum magazines in saltwater environments develop corrosion that can bind the follower. Polymer magazines left in direct sunlight for extended periods can degrade from ultraviolet exposure. Each material has its vulnerabilities, and experienced shooters learn to match their magazine material to their operating environment. Desert, polymer or coated aluminum. Maritime, stainless steel or polymer. Arctic, polymer with cold-rated springs. The best material depends on where you are and what you are doing. As manufacturing technology continues to advance, the line between material categories blurs. Metal injection molding, or MIM, allows complex metal shapes to be produced with near polymer ease of manufacturing. Advanced polymers approach metal in strength and stiffness. Composite materials combine the properties of multiple base materials into engineered hybrids. The magazine of the future may not be steel, aluminum, or polymer. It may be something that does not have a name yet, engineered from the molecular level to provide the exact combination of properties that optimal magazine performance demands. The materials war, like the magazine itself, keeps evolving. Open a magazine. Any magazine. Strip away the body and look at what is inside. You will find three things: a spring, a follower, and a set of feed lips at the top. That is it. Three components. Three pieces of metal or polymer that must work in precise harmony every single time the weapon fires. The spring pushes upward. The follower distributes that force evenly across the cartridge stack. The feed lips control the angle and position at which the top round is presented to the bolt. If any one of these three components fails, even momentarily, the weapon stops working. Let us start with the spring because it is the most misunderstood component in the entire magazine. The magazine spring is a compression spring, either a flat wire zigzag pattern or a coiled wire design that provides upward force to push the follower and the cartridge stack toward the feed lips. When the magazine is fully loaded, the spring is at maximum compression. As rounds are fired and the stack shortens, the spring extends and the force decreases. The spring must provide enough force when nearly empty to push the last round into the feed position, but not so much force when fully loaded that it prevents the bolt from stripping the top round. The most pervasive myth in the firearms world is that leaving a magazine loaded for an extended period will weaken the spring. This belief is so widespread that entire training doctrines have been built around it. Rotate your magazines, download them by 2 rounds, never leave them loaded for more than a month. The reality, according to metallurgical science, is more nuanced. Springs weaken through cyclic fatigue, which is repeated compression and extension. A spring held at a constant compression, even for years, does not lose significant force. The act of loading and unloading the magazine thousands of times is what eventually weakens the spring, not the act of leaving it loaded. This does not mean magazine springs are immortal. They are not. A spring that has been cycled thousands of times will eventually take a set, meaning it loses a small amount of its free length and corresponding force. But the number of cycles required to produce measurable degradation in a quality magazine spring is far higher than most shooters will ever achieve. Magpul has tested PMAG springs through 3,000 loading cycles without measurable force degradation. The United States military specifies a minimum of 3,000 cycles for STANAG magazine springs. In practical terms, your magazine spring will outlast your interest in shooting, your vehicle, and possibly your mortgage. The flat wire spring, used in most modern rifle magazines, is a strip of spring steel formed into a zigzag or W pattern. This design provides a longer spring length in a compact vertical space, which allows for more consistent force across the spring's compression range. The zigzag pattern also self-centers within the magazine body, reducing the tendency to bind against the walls. The flat wire spring was a significant improvement over the older round wire coil springs used in early STANAG magazines, which could kink, twist, and bind inside the narrow magazine body. Stainless steel has become the preferred material for magazine springs, replacing the music wire, high-carbon steel, used in earlier designs. Stainless steel springs resist corrosion, which is critically important because magazine springs operate in an environment exposed to moisture, cleaning solvents, and the byproducts of combustion. A corroded spring develops surface pits that act as stress concentrators, dramatically reducing fatigue life. A stainless steel spring in a well-maintained magazine can function reliably for the entire service life of the weapon, and quite possibly the service life of the weapon's successor. The follower is the platform that sits on top of the spring and below the cartridge stack. Its job sounds simple: distribute the spring's upward force evenly across the base of the bottom cartridge. But the follower must do this while remaining perfectly level inside the magazine body. If the follower tilts, the cartridge stack shifts, and the top round can move out of alignment with the feed lips. A tilted follower is the most common cause of feeding failures in box magazines, and preventing follower tilt is one of the most important engineering challenges in magazine design. The original STANAG magazine follower was a simple flat piece of aluminum alloy with a slightly raised center section. It had no anti-tilt features whatsoever. Inside the magazine body, it could rock, tilt, and cock sideways with remarkable ease, particularly when only a few rounds remained in the magazine. When the follower tilted, the last few rounds would nosedive, jamming into the feed ramp instead of being presented cleanly to the bolt. This single design flaw plagued the M16-M4 platform for over 40 years and was responsible for an unknowable number of weapon malfunctions in combat. The green follower, introduced in the early 2000s, was the first attempt to address the tilt problem in STANAG magazines. It added wider bearing surfaces and a modest anti-tilt geometry. It was better than the original, but still imperfect. The tan follower, developed by the Marines and adopted as the improved magazine in the mid-2000s, went further with a four-way anti-tilt design that used extended legs to contact all four internal walls of the magazine body. The improvement was dramatic. Feed-related malfunctions dropped by more than half. The color coding, from black to green to tan, allowed armorers to identify magazine generation at a glance. Magpul's PMAG follower took the anti-tilt concept to its logical conclusion. The PMAG follower is an injection molded polymer component with four extended legs that maintain continuous contact with the magazine body's internal ribs. The follower literally cannot tilt because its bearing surfaces span the full width of the magazine in both axes. Additionally, the follower's upper surface is contoured to match the geometry of the cartridge base, cradling each round and preventing lateral movement. It is over-engineered in the best possible way. Over-engineered to the point where the problem it solves has been effectively eliminated. Feed lips are the final and most critical element of the magazine's internal trilogy. The feed lips are the shaped edges at the top of the magazine body that retain the top round in position and control the angle at which it is presented to the bolt face. In a single feed magazine, the two lips converge to center the round. In a double feed magazine, the lips are parallel and the bolt alternately strips round from left and right. The geometry of the feed lips, their angle, their spacing, their height, determines whether rounds feed smoothly or jam catastrophically. Feed lip spread is the nightmare scenario for any magazine. Over time, the repeated stripping of rounds across the feed lips can cause them to gradually move apart. As the spacing increases, rounds sit higher and at a steeper angle, changing the presentation geometry. Eventually, rounds can pop free of the feed lips entirely, a condition known as a pop-out, or they can double stack at the feed position, causing a catastrophic double feed. Feed lip spread is the primary wear mechanism that limits magazine service life, and it is the reason that all magazines, regardless of material, are technically consumable items with finite lifespans. The relationship between feed lip geometry and the weapon's feed ramp is a design partnership that must be engineered as a system. The feed lips present the round at a specific angle and height. The feed ramp, machined into the barrel extension or receiver, guides the round from the magazine into the chamber. If the feed lip presentation angle does not match the feed ramp angle, the round will either strike the ramp too high, causing a jam, or enter the chamber at an angle, causing incomplete locking. Magazine and weapon must be designed together, or at least designed to the same dimensional standard. This is what STANAG 4179 achieves, a standardized interface between magazine and weapon that ensures interoperability. The constant force spring is an advanced concept that has appeared in some premium magazine designs. A conventional compression spring provides less force as it extends, meaning the last few rounds in a magazine are pushed with less force than the first few. A constant force spring, using a coiled ribbon of spring steel that unrolls from a drum, provides nearly identical force throughout its extension range. This ensures that the last round feeds with the same authority as the first. The concept has been used in some drum magazines and experimental designs, but has not yet achieved widespread adoption in standard box magazines due to cost and complexity. Magazine body ribs, the raised ridges stamped or molded into the interior walls of the magazine, are another subtle but critical design element. Ribs reduce the surface area of contact between the magazine wall and the cartridge stack, decreasing friction and allowing smoother feeding. They also stiffen the magazine body against lateral compression. In a steel STANAG magazine, the ribs are stamped during the forming process. In a PMAG, they are molded as integral features. In an AK magazine, the ribs are pronounced and widely spaced, reflecting the design's philosophy of generous clearances over tight precision. The base plate, often overlooked, plays a role in magazine reliability that extends beyond simply closing the bottom of the magazine body. In many designs, the base plate retains the spring under compression. If the base plate detaches, whether from damage, improper installation, or a failed retention mechanism, the spring and follower launch out of the magazine body like a metallic jack in the box, scattering components across the ground and rendering the magazine instantly useless. Spring launches during magazine disassembly are a rite of passage for new shooters and a source of endless amusement for experienced ones who have learned to reassemble a magazine by feel after chasing a spring across a garage floor. Extended base plates, popular in the competitive shooting community, add length to the bottom of the magazine and increase capacity by 1 to 3 rounds. They also provide a larger gripping surface for magazine changes, which can be critical during speed reloads and competition. Companies like Taurun Tactical, SLR Rifle Works, and Henning Group produce base plates for virtually every popular pistol and rifle magazine on the market. Some are aluminum, some are polymer, some are titanium. All serve the same purpose: a few more rounds and a faster grab during the reload. The interaction between all 3 internal components, spring, follower, and feed lips, creates a system that is simultaneously simple and unforgiving. Each component must perform within tight tolerances. The spring must provide the right force curve. The follower must remain level. The feed lips must maintain their geometry. When all 3 work correctly, the magazine feeds invisibly, round after round, with mechanical perfection. When any one fails, the entire system fails. There is no graceful degradation. There is no partial function. It works or does not. This binary nature of magazine reliability is what makes magazine engineering both challenging and consequential. An engine that loses 10% of its power still runs. A bridge that weakens slightly still stands. But a magazine that feeds 29 out of 30 rounds has a failure rate that could get someone killed. In the magazine world, anything less than perfect is a defect. And achieving perfection consistently across millions of units produced under the pressures of mass manufacturing is one of the most demanding quality control challenges in the consumer products industry. Every PMG, every STANAG, every Glock magazine is either perfect or is garbage. There is no middle ground. As we leave the internal world of the magazine, remember that every time you load a round and it feeds smoothly into the chamber, 3 components you have never thought about are performing flawlessly inside a container you take for granted. The spring is pushing, the follower is leveling, the feed lips are guiding, and the weapon fires. It is a small miracle of engineering, repeated billions of times a year across every shooting range, battlefield, and hunting ground on Earth. The hidden orchestra plays on, unseen and unappreciated, until the one time it does not. We have spent considerable time celebrating the magazine's triumphs. Its elegant engineering, its role in transforming warfare, its quiet, reliable perfection. Now it's time to talk about the failures. Because the history of the magazine is not just a story of mechanical progress. It is also a story of catastrophic breakdowns, institutional stubbornness, and the soldiers who paid the price when the device they depended on for their lives simply stopped working. This is the dark side of the magazine's history, and it is darker than most people realize. The Chauchat light machine gun, issued to French and American forces in World War I, holds the dubious distinction of being the worst magazine-fed weapon ever issued to a major military. The Chauchat's 20-round magazine was a long, curved, semicircular affair made from thin stamped steel with open windows on each side that were intended to allow the operator to see how many rounds remained. In theory, this was a useful feature. In practice, those open windows allowed mud, dirt, and debris to enter the magazine continuously. In the waterlogged trenches of the Western Front, this was catastrophic. The Chauchat's magazine was designed for the 8mm Lebel cartridge, a sharply tapered round that required the magazine's extreme curvature. The combination of open side panels, thin metal construction, and aggressive curvature created a magazine that dented, bent, and fouled with almost every use. American troops issued the Chauchat in .3006. Springfield fared even worse, because the rechambered version used a straight-sided cartridge in a magazine designed for a tapered one. The results were predictable: constant jams, failures to feed, and a malfunction rate so high that many soldiers abandoned the weapon entirely and fought with rifles instead. American doughboys in the Meuse-Argonne Offensive of 1918 reported that the Chauchat jammed on average every few rounds. Entire magazines sometimes failed to feed a single round to completion. Gun crews would carry 4 or 5 Chauchats, so that when one jammed beyond immediate clearance, they could simply grab another. The weapon was so universally despised that after the war, nearly every surviving Chauchat was scrapped, destroyed, or sold to third-world militaries who could not afford to be choosy. The Chauchat's magazine was not the only thing wrong with the weapon, but it was the thing most wrong. The Ross rifle, issued to Canadian forces early in World War I, had magazine problems of a different kind. The Ross was a straight pull-bolt action with a complex magazine system that was sensitive to dirt and the quality of ammunition. In the muddy conditions of the Western Front, the Ross's magazine frequently failed to feed, and the bolt could be reassembled incorrectly after cleaning, creating a condition where it could blow out rearward into the shooter's face upon firing. Canadian soldiers threw away their Ross rifles and picked up Lee Enfields from fallen British soldiers. The Ross was withdrawn from frontline service in 1916. The most consequential magazine failure in modern history occurred in Vietnam. When the M16 rifle was first deployed to American forces in the mid-1960s, it arrived with a set of problems that turned a promising weapon into a soldier's nightmare. The magazines were a significant part of the problem. The original 20-round aluminum magazines used a flat follower that tilted easily, causing nose dives and failures to feed. The magazines were also issued without cleaning instructions, because the weapon had been marketed as self-cleaning. Combined with the wrong type of propellant powder, which left excessive fouling, and a chrome line chamber that had been deleted as a cost-saving measure, the M16 became a jamming machine. Reports from Vietnam described M16s jamming constantly during firefights. Soldiers were found dead with cleaning rods in their hands, trying to clear jammed rounds from their weapons in the middle of combat. A 1967 congressional investigation led by Representative Richard Ichord revealed that the M16's malfunction rate in Vietnam was horrifyingly high, with some units reporting that up to 1 in 5 weapons experienced a stoppage during any given engagement. The magazine was not the only problem, but the flat follower and the thin aluminum body that dented easily were significant contributors to the weapon's unreliability. The M16 saga is a case study in how institutional failure compounds engineering problems. The Army Materiel Command had changed the propellant powder specification without adequately testing the new powder in the M16. The magazines were produced to the lowest bidder with inadequate quality control. Cleaning kits were not issued because acknowledging the need for cleaning would have contradicted the marketing claims of self-cleaning operation. Each individual problem was manageable. Together, they created a systemic failure that killed American soldiers. The magazine, by itself, did not cause the disaster, but it was a willing accomplice. The British L85A1, the original version of the SA-80 bullpup rifle adopted in 1985, suffered from magazine-related problems that embarrassed the British military for nearly 2 decades. The L85A1 used proprietary magazines that were not STANAG compatible, and these magazines were plagued by weak springs, unreliable followers, and feed lips that spread after minimal use. The weapon's magazine release was positioned where it could be inadvertently activated during normal handling, causing magazines to drop free at inopportune moments. British soldiers in the Gulf War and Bosnia developed a deep and abiding mistrust of their own weapons feeding system. The L85A1 was so unreliable that the Ministry of Defense contracted Heckler & Koch to completely redesign the weapon, producing the L85A2 in 2001. The redesign addressed most of the weapon's internal problems, but the magazine remained an issue. It was not until the later adoption of Magpul PMAG magazines, a STANAG variant specifically designed for the SA-80 platform, that the magazine reliability problem was fully resolved. The entire saga, from initial adoption in 1985 to reliable magazine feeding in the late 2000s, spanned over 20 years. 20 years of a front-line infantry weapon that its own soldiers did not trust. The Bren gun, often cited as one of the best light machine guns of World War II, had a magazine controversy that was more philosophical than mechanical. The Bren used a top-mounted curved box magazine, holding 30 rounds of .303 British. The magazine itself was reliable, but its 30-round capacity was criticized as insufficient for a squad automatic weapon. The German MG-42 used 250 round belts. The Soviet DP-28 used 47 round pans. 30 round from a box magazine meant the Bren gunner was changing magazines every few seconds of sustained fire. The magazine worked. The question was whether 30 rounds was enough for the role the weapon was asked to fill. In the modern era, magazine failures tend to be less dramatic, but no less consequential. The original Sig Sauer P320 pistol, adopted by the United States military as the M17 and M18, experienced reports of magazine-related feeding issues with certain ammunition types during early deployment. SIG addressed these through iterative improvements to the magazine's internal geometry, but the initial reports raised concerns about the reliability of a weapon that had just won the largest handgun contract in American military history. In the age of social media, every malfunction is documented, photographed, and debated by millions of armchair experts worldwide. Magazine recall events, while rare, do occur. In 2018, a major ammunition manufacturer recalled a batch of magazines for a popular pistol platform after discovering that a tooling error had produced feed lips with incorrect geometry. The affected magazines would feed normally for the first several rounds, but would consistently cause a nosedive jam at round 8. The failure was so consistent that it was almost certainly a manufacturing defect rather than a design problem. The same magazine design, produced on corrected tooling, functioned perfectly. Quality control had caught the issue after approximately 15,000 magazines had shipped. Finding all 15,000 proved considerably more challenging. Counterfeit magazines represent a growing problem in the global firearms market. Fake Magpul PMAGs, produced in unregulated factories in Southeast Asia, have been documented entering the American and European markets at prices that undercut genuine products. These counterfeits often look identical to legitimate PMAGs, but are molded from inferior polymer with different mechanical properties. The feed lips may be softer. The follower may be dimensionally incorrect. The spring may be substandard. From the outside, the magazine looks perfect. On the inside, it is a failure waiting to happen. And the shooter typically discovers this at the worst possible moment. Temperature-induced failures are among the most insidious magazine problems because they are intermittent and difficult to diagnose. A magazine that functions perfectly at room temperature may fail at extreme cold or extreme heat. Steel contracts in cold weather, tightening the clearances between the magazine body and the cartridge stack. Lubricants thicken, increasing friction. Springs lose force. In Arctic conditions, these effects can combine to produce a magazine that feeds every other round at best. Soviet weapons, designed for Siberian winters, used generous clearances and dry lubrication to mitigate cold weather feeding problems. Western weapons, designed primarily for temperate climates, have historically been more susceptible. Sand and dust ingestion is the magazine failure mode most familiar to veterans of operations in Iraq and Afghanistan. Fine desert sand penetrates magazine bodies through the gap between the feed lips and accumulates on the follower, the spring, and the cartridge surfaces. Over time, the accumulated grit increases friction to the point where the spring cannot push the cartridge stack upward with sufficient force. The result is a sluggish feed that deteriorates progressively. The magazine might feed the first 20 rounds perfectly but slow and stutter on the last 10 as the follower drags through accumulated debris. Every magazine failure, from the Chauchat's open windows to the M16's flat follower, carries the same fundamental lesson. The magazine is a system, and every element of that system matters. The material matters. The spring matters. The follower matters. The feed lips matter. The ammunition matters. The environment matters. Remove any one element from consideration. Cut any one corner. Accept any one compromise, and the system will eventually fail. And in the context of a weapon, failure is not an inconvenience. It is a potentially fatal event. The magazine, for all its simplicity, does not forgive mistakes. The failures documented in this chapter were not inevitable. Every one of them was preventable. Better design, better materials, better testing, better quality control, better institutional decision-making. The Chauchat's open windows could have been closed. The M16's follower could have been anti-tilt from the start. The L85A1's magazines could have been STANAG compatible. In each case, someone made a decision, whether through ignorance, cost pressure, or institutional inertia, that prioritized something other than reliability. And soldiers paid for those decisions with their lives. The lesson is simple, even if the execution is not. Do not compromise on a magazine. Ever. Everything we have discussed in this documentary, every tube, box, drum, belt, clip, spool, and helix shares a common assumption. The ammunition is a brass-cased metallic cartridge, a cylinder of drawn brass containing primer, powder, and projectile. This assumption has governed magazine design for over 160 years. But what happens when the cartridge itself changes? When the brass case is replaced by polymer? When the case disappears entirely? When the propellant wraps around the bullet instead of sitting behind it? The magazine must change with the ammunition. And some of those changes are genuinely revolutionary. The Heckler & Koch G11, developed between 1968 and 1990, remains the most ambitious attempt to field a caseless ammunition weapon system. Caseless ammunition eliminates the brass cartridge case entirely. The propellant itself is formed into a solid block with the bullet embedded in one end and the primer at the other. When fired, the entire propellant block is consumed, leaving no case to extract or eject. This eliminates the extraction and ejection cycle, dramatically simplifying the weapon's action and theoretically increasing its rate of fire. The G11's magazine was unlike anything before or since. It held 50 rounds of 4.73 by 33 millimeters caseless ammunition in a horizontal box that sat on top of the weapon, parallel to the barrel. Rounds were stacked vertically in the magazine and fed downward into a rotary chamber that indexed each round into firing position. The rotary chamber could hold 3 rounds simultaneously, allowing the G11 to fire a 3-round burst at 2,100 rounds per minute before the shooter even felt the recoil of the first shot. The entire system, magazine, rotary chamber, and action was a mechanical tour de force of German engineering. The G11's magazine solved problems that traditional magazines never had to face. Caseless ammunition is more fragile than brass-cased ammunition because there is no protective brass envelope around the propellant. The rounds can chip, crack, or break if subjected to rough handling. The magazine had to protect 50 fragile rounds from mechanical shock while still feeding them reliably into the rotary chamber. The solution was a tightly packed column with minimal internal clearance, cushioned by the fit between adjacent rounds. It worked, but it required ammunition manufactured to much tighter dimensional tolerances than traditional cartridges. The G11 program was canceled in 1990, a casualty of German reunification and the massive defense budget reallocations that followed. The weapon had passed extensive military trials and was approved for adoption by the Bundeswehr when the political ground shifted beneath it. The G11 remains, to this day, the most technologically advanced infantry weapon ever to reach the brink of mass production without actually crossing that threshold. Its magazine, its caseless ammunition, and its rotary chamber represented a quantum leap in small arms design. a leap that nobody, ultimately, was willing to take. Telescoped ammunition, where the bullet is partially or fully embedded within the propellant rather than sitting ahead of it, represents a different approach to cartridge revolution. Telescope rounds are shorter than conventional cartridges of the same caliber and power, because the bullet occupies space within the propellant column rather than extending beyond it. A shorter cartridge means a shorter magazine, or the same size magazine with more rounds. The volume savings are significant. A telescope round can be 30 to 40% shorter than its conventional equivalent. The United States military's next-generation squad weapon program, NGSW, has brought telescoped and hybrid ammunition concepts closer to fielding than at any point since the G11. The program evaluated 3 competing designs from Textron Systems: telescope polymer case, Sig Sauer hybrid metallic case, and General Dynamics, conventional but with a telescope bullpup configuration. Sig Sauer won the competition in 2022 with the XM7 rifle and XM250 automatic rifle, both chambered in 6.8 by 51 millimeters, a high-pressure cartridge using a hybrid steel and brass case. The XM7 uses a detachable 20-round box magazine that, despite the novel cartridge, is functionally conventional in its feeding mechanism. Textron's NGSW entry, which lost the competition, used a true case telescoped round and featured a magazine that would have been genuinely novel in military service. The telescope cartridge's shorter length allowed a 20-round magazine to be significantly more compact than a conventional magazine of equivalent capacity. The weapon's rotating chamber, which aligned the telescoped round with the barrel before firing, required a different feed geometry than conventional bolt-face stripping. Though Textron did not win the NGSW contract, their telescope technology continues to be developed and may appear in future weapon systems. Polymer-cased ammunition, which replaces the traditional brass cartridge case with a lighter polymer case, has been under development for decades and is now approaching practical maturity. Companies like True Velocity, now part of the NGSW ecosystem, have demonstrated polymer-cased ammunition that is 30% lighter than brass equivalent. The magazine implications are significant. Lighter ammunition means more rounds can be carried for the same weight penalty, or the same number of rounds can be carried with less weight. A soldier carrying 210 rounds of polymer-cased 6.8 millimeters weighs noticeably less than one carrying 210 rounds of brass-cased ammunition. Polymer-cased ammunition introduces new challenges for magazine design. The polymer case has different friction characteristics than brass, which affect how rounds slide against each other and against the magazine walls. The case may be slightly more compressible than brass, which changes the pressure distribution within the cartridge stack. And the thermal properties of polymer differ from brass. Polymer insulates more effectively, which means heat from sustained fire is retained in the chamber rather than being conducted away through the case. Magazine designers working with polymer-cased ammunition must recalibrate their understanding of how rounds behave inside the box. Electronic round counters represent one of the most practical near-term innovations in magazine technology. Several companies have developed magazine base plates with embedded microelectronics that count the number of rounds remaining in the magazine. A small LED display or wireless transmitter communicates the round count to the shooter. The technology uses either an optical sensor that detects rounds passing the feed lips or a pressure sensor that measures the spring compression to estimate round count. Neither approach is perfect, but both are functional and represent the first step toward a truly smart magazine. The United States Army's Integrated Visual Augmentation System, IVS, a heads-up display system based on Microsoft's HoloLens platform, includes plans for weapon integration that could incorporate magazine round count data. Imagine a soldier's heads-up display showing not just navigation and targeting data, but also a real-time count of remaining ammunition in the currently inserted magazine and in each spare magazine on the soldier's kit. The magazine, connected wirelessly to the soldier's combat network, would become a data source as well as an ammunition container. The smart magazine would finally know how much fight it has left. Additive manufacturing the industrial cousin of consumer 3D printing, is beginning to influence magazine production at the commercial level. Metal additive manufacturing can produce magazine components with internal geometries that are impossible to achieve through traditional stamping or machining. A follower with internal lattice structures that reduce weight while maintaining strength. Feed lips with optimized curvatures that would require multiple machining setups to produce conventionally. Magazine bodies with variable wall thickness, thicker at stress points and thinner where weight can be saved. The technology is currently too expensive for mass production, but costs are falling rapidly. The concept of a self-loading magazine has been explored in several patent applications and prototype designs. The idea is a magazine that can be refilled quickly from a bulk ammunition source without manually loading each round. One approach uses a hopper that gravity feeds loose rounds into a magazine through an automated indexing mechanism. Another uses pre-loaded disposable inserts that slot into a reusable magazine body. A third approach stores ammunition in a flexible belt that is machine-loaded into a box magazine configuration. None of these systems has achieved commercial production, but the demand for faster magazine loading drives continued innovation. The magazine speed loader market has grown significantly as a practical intermediate solution. Devices like the Mag-Lula Up-Lula for pistol magazines and the Mag-Lula Strip-Lula for rifle magazines use mechanical advantage to reduce the thumb force required for loading and increase the speed of the process. The Up-Lula, a simple lever-actuated device that grips the magazine and presses rounds in with a rocking motion, has become one of the most popular firearms accessories in the world. It does not change the magazine's design. It changes the human's interaction with the magazine, and sometimes that is enough. Electromagnetic feeding systems exist in conceptual designs and a handful of experimental prototypes. Instead of a mechanical spring, an electromagnetic system would use powered coils to push the follower upward, with the force adjustable in real time based on the number of remaining rounds. The advantages are obvious. Perfectly consistent feed force regardless of round count. No spring fatigue, no mechanical wear. The disadvantages are equally obvious. The system requires electrical power, adds significant weight and complexity, and introduces a catastrophic failure mode that mechanical springs do not have. If the battery dies, the magazine dies with it. Perhaps the most radical reimagining of the magazine comes from directed energy weapons research. If infantry weapons eventually transition from kinetic projectiles to directed energy, whether laser, particle beam, or some other exotic mechanism, the concept of the magazine changes fundamentally. Instead of storing physical projectiles, the magazine becomes a power cell. Instead of feed lips, there are electrical contacts. Instead of a spring, there is a capacitor bank. The magazine as ammunition container would cease to exist, replaced by the magazine as energy reservoir. The shape might be the same. The function would be unrecognizable. But that future, if it comes at all, is decades away. For now, and for the foreseeable future, the magazine remains a container of kinetic projectiles pushed by a spring through a set of feed lips. The materials are changing. The electronics are coming. The ammunition itself is evolving. But the fundamental concept, store multiple rounds and present them one at a time to the weapon's action, has remained constant since James Paris Lee's 1879 patent. And it will likely remain constant for as long as humans use kinetic projectile weapons. The form may change. The function will not. The magazine of the future will be lighter, smarter, more durable, and probably cheaper to produce than anything available today. It will talk to the soldier's heads-up display. It will be printed from advanced materials in forward operating bases. It will feed ammunition types that have not been invented yet. But it will still be, at its core, a box with a spring and a follower, doing what magazines have always done, keeping the weapon shooting. The technology evolves. The mission never changes. The magazine does not exist in isolation. It exists within an ecosystem of accessories, modifications, carrying solutions, and cultural practices that has grown up around it over the past century, like coral around a reef. This ecosystem is enormous. The global market for magazine accessories, from pouches to extensions to speed loaders, is worth hundreds of millions of dollars annually. An entire industry exists not to make magazines, but to make magazines easier to carry, faster to load, quicker to swap, and more effective in use. The magazine has spawned its own economy. The magazine pouch is the oldest and most fundamental magazine accessory. Military forces have been designing purpose-built containers for carrying spare magazines since the adoption of the first detachable magazine rifles. The British military issued leather magazine pouches for the Lee Enfield in the 1890s. American forces carried M1 Garand in block clips and cloth bandoliers. German soldiers used distinctive leather pouches mounted on the belt for Mauser stripper clips. Each generation of magazine-carrying solution was tailored to the specific magazine it carried, and each reflected the tactical doctrine of its era. Modern magazine-carrying systems have evolved into an engineering discipline of their own. The MAL system, modular lightweight load-carrying equipment, uses a grid of nylon webbing that allows magazine pouches to be attached in any position on a vest, belt, or plate carrier. Kydex magazine pouches, molded from thermoform polymer, provide retention through friction fit and allow one-handed extraction with a sharp tug. Elastic magazine pouches compress to the magazine's profile and expand when the magazine is inserted. Each design philosophy represents a different balance between security, speed of access, weight, and versatility. The chest rig, a minimal load carrying platform designed primarily to hold magazines across the front of the torso, has become iconic in military and tactical culture. Designs range from the simple Chinese-type 56 chest rig, a canvas affair with pockets for 3 AK magazines that has been photographed in every guerrilla conflict since the 1960s, to modern micro-chest rigs from companies like Sparita Systems and Haley Strategic that hold 4 to 6 rifle magazines in a low-profile, highly adjustable package. The chest rig is, in essence, a wearable magazine rack. Its design is driven entirely by the dimensions and number of magazines it must carry. Magazine couplers, devices that join 2 magazines side by side or end to end, are one of the simplest and most popular magazine accessories. The concept is straightforward. Attach a loaded spare magazine to the one currently in the weapon so that a reload requires only pulling the empty magazine out, flipping or sliding the assembly, and inserting the loaded magazine. Magpul's MagLink, a polymer clamp that joins 2 mags at a slight angle, is the most commercially successful implementation. But soldiers have been improvising magazine couplers from tape, rubber bands, and metal clamps for as long as detachable magazines have existed. Necessity is the mother of duct tape engineering. Pull tabs, Ranger plates, and extraction aids are small accessories that make a big difference in the speed and reliability of magazine extraction from pouches. A pull tab is a loop of nylon or paracord attached to the base of the magazine that provides a positive grip point for pulling the magazine from a tight pouch. A Ranger plate is an extended base plate with a flared bottom that serves the same purpose while also protecting the base plate from impacts. These accessories cost a few dollars each and can shave fractions of a second from each reload. In competitive shooting, where matches are won by hundredths of a second, those fractions add up. The magwell funnel is an accessory that attaches to the weapon rather than the magazine, but its purpose is entirely magazine-centric. A magwell funnel is a flared guide that widens the opening of the magazine well, making it easier to guide the magazine into position during a fast reload. In competition shooting, where reloads are performed at full speed under time pressure, the magwell funnel can mean the difference between a smooth insertion and a fumbled magazine that costs seconds. Magwell funnels are standard equipment on virtually every competitive pistol and are increasingly common on rifles as well. Magazine identification systems have emerged as a practical necessity for shooters who own multiple magazines for the same weapon. Colored base plates allow quick visual identification. Blue base plates for training magazines loaded with dummy rounds. Red base plates for magazines with specific ammunition types, number plates for tracking individual magazine round counts and maintenance history. Magpul produces base plates in over a dozen colors. The aftermarket offers even more variety. Some competitive shooters number each magazine and log its performance, tracking feeding failures and round counts the way a mechanic tracks the service history of individual engine components. The culture of the reload has become a competitive discipline in its own right. Practical shooting sports like USPSA, IPSC, and .3 gun place enormous emphasis on reload speed and efficiency. Top competitors can perform a standing rifle magazine change in under 1.5 seconds. Pistol reloads under 1 second. Shotgun reloads, using the quad loading technique we discussed in the tubular magazine chapter, in under 1.2 seconds per 4 rounds. These athletes train for hundreds of hours to shave milliseconds from their reload times. And the equipment they use, from magazines to pouches to magwell funnels, is optimized for speed at every level. The tactical reload, where a partially spent magazine is swapped for a fresh one before it runs empty, has become standard doctrine for military and law enforcement operations. The partially spent magazine is retained, usually stowed in a pocket or dump pouch, rather than dropped on the ground. This practice treats magazines as valuable assets to be conserved rather than disposable items to be discarded. The ritual of the tactical reload: feel the weapon go to slide lock, press the release, index the fresh magazine, insert, release the slide, assess the threat, has been drilled into millions of soldiers and officers worldwide. It is choreography, violent, rehearsed, life or death choreography. The emergency reload, performed when the weapon runs completely dry, is the faster and more desperate cousin of the tactical reload. The empty magazine is dropped rather than retained. The shooter's support hand is already reaching for the fresh magazine before the empty one hits the ground. The fresh magazine is driven into the magazine well with authority, and the slide or bolt is released. The entire sequence, from empty weapon to first round chambered, takes a trained shooter 1 to 2 seconds. It is practiced until it becomes reflexive, because the moments after a weapon runs empty are the most vulnerable moments a shooter will experience. The dump pouch, a simple collapsible pouch that hangs from a belt or plate carrier, exists solely to receive empty or partially spent magazines during reloads. It is the magazine's retirement home, a temporary repository for magazines that have done their job and are waiting to be refilled. The dump pouch is unglamorous, inexpensive, and absolutely essential for anyone who does not want to leave a trail of expensive magazines on the ground. It is the most practical accessory in the entire tactical ecosystem, and it costs about the same as a decent lunch. Magazine maintenance tools form their own subcategory of the accessory market. Disassembly punches for removing floor plates. Spring testers that measure the force output of magazine springs. Feed lip gauges that check whether the lip spacing is within specification. Ultrasonic cleaners that remove sand, carbon, and debris from magazine internals. For the obsessive shooter, magazine maintenance is a ritual as regular and important as cleaning the weapon itself. Because a perfectly maintained weapon with a neglected magazine is a weapon waiting to malfunction. The magazine loading party is a peculiar social ritual of the shooting community. Before a major competition or training event, groups of shooters gather to load hundreds of magazines. The process is repetitive, somewhat meditative, and unexpectedly social. Stories are told. Techniques are debated. New magazines are admired. Old magazines are retired. Speed loaders are shared. The loading party is the firearms community's equivalent of a quilting bee or a barn raising. Communal labor organized around a shared purpose, accompanied by conversation and the distinctive metallic click of brass being pushed into polymer and steel. Magazine collecting is a surprisingly active niche within the broader firearms collecting community. Rare and historical magazines, particularly those from discontinued weapons or limited production runs, can command significant prices. Original World War II Thompson drum magazines sell for hundreds of dollars. Pristine Bakelite AK-74 magazines fetch premium prices. Pre-ban high-capacity magazines in states that grandfather existing stocks are worth multiples of their original cost. The magazine, humble and utilitarian, has become a collectible artifact valued for its history, its rarity, and its connection to specific weapons and conflicts. The magazine has also become a canvas for personal expression. Custom Cerakote finishes in every color imaginable. Laser engraved patterns, logos, and artwork. Vinyl wraps with camouflage patterns or pop culture references. Hand-stippled polymer for enhanced grip. Magazines that started as identical factory products leave the customization pipeline as unique, personalized objects that reflect their owner's personality and aesthetic preferences. It is a form of mechanical folk art practiced by millions of people worldwide, turning a utilitarian device into something distinctly their own. The magazine's ecosystem tells us something important about the relationship between humans and their tools. We do not just use tools. We accessorize them. We personalize them. We optimize them. We create communities around them. We develop rituals for their use and maintenance. The magazine, a simple box with a spring, has generated an ecosystem of products, practices, and culture that is vastly more complex than the device itself. The magazine is not just a component. It is a node in a network of human activity that spans manufacturing, commerce, competition, defense, law, and art. Not bad for a box with a spring. We have talked about what magazines do. We have talked about how they fail. We have talked about what they are made from. Now let us talk about how they are actually made. Because the gap between a design on paper and a functioning magazine in your hand is filled with machinery, precision, labor, and an obsessive attention to detail that most shooters never think about. Every magazine you have ever loaded began as raw material. A coil of steel, a billet of aluminum, or a hopper of polymer pellets. Turning that raw material into a device that feeds ammunition reliably is a manufacturing challenge that requires the precision of watchmaking at the scale of automobile production. Steel magazine production begins with a flat sheet of carbon steel, typically between 0.8 millimeters and 1.2 millimeters thick. The sheet is fed into a progressive stamping die, a massive multi-station press that performs a series of operations in sequence. The first station punches the blank outline. The second draws the blank into a U-shaped channel. The third folds the sides upward. The fourth forms the feed lip geometry. Each station adds another fold, bend, or feature, and the steel moves through the die at a rate of 40 to 60 parts per minute. A single progressive die can cost hundreds of thousands of dollars to manufacture, but once operational, it produces magazine bodies with mechanical precision at astonishing speed. The AK-47 magazine body, despite its reputation for crude simplicity, requires over a dozen individual forming operations. The distinctive curve must be precisely controlled to match the 7.62 by 39 millimeters cartridge's taper. The rear seam is welded using either spot welding or continuous seam welding, depending on manufacturer and the era of production. Early Soviet magazines were seam welded using labor-intensive techniques. Later production, particularly Chinese and Eastern European, shifted to faster but less refined spot welding. The differences are visible on close inspection. Seam welded magazines have a smooth, continuous joint, while spot welded magazines show a line of circular weld marks along the spine. Aluminum magazine production follows a similar stamping process, but uses 6061 or 7075 aluminum alloy sheet stock. Aluminum is softer than steel and forms more easily, which allows for faster die speeds and longer die life. However, aluminum's lower hardness means the feed lips, which must maintain precise geometry under repeated loading stress, are more susceptible to deformation. Some manufacturers heat treat the feed lip area after forming to increase hardness at this critical point. Others, like Duramag, use 7075 aluminum throughout, which is significantly harder than 6061, but more expensive and more difficult to form. Polymer magazine production is fundamentally different from metal stamping. Instead of shaping a flat sheet, polymer magazines are injection molded. Molten polymer is injected under high pressure into a steel mold cavity that is the exact negative shape of the desired part. The mold closes, the polymer fills every feature of the cavity in milliseconds. The part cools and solidifies, the mold opens, and the finished magazine body is ejected. A modern injection molding machine can produce a complete PMAG body in under 30 seconds, including cooling time. The mold itself, a precision machine block of hardened steel, costs hundreds of thousands of dollars, but can produce millions of parts before requiring replacement. The polymer pellets used for magazine molding are not off-the-shelf materials. They are proprietary compounds blended to specific formulations by the magazine manufacturer. Magpul's polymer blend, for example, includes glass fiber reinforcement for stiffness, impact modifiers for toughness, UV stabilizers for sunlight resistance, and proprietary additives whose composition is a closely guarded trade secret. The pellet formulation is developed through years of testing and iteration because the mechanical properties of the finished magazine depend entirely on the composition and processing of the raw polymer. Change the formulation by even a few percent, and the magazine may behave differently under stress. Spring manufacturing is its own specialized discipline. Magazine springs are formed from steel wire, either round wire for coiled springs or flat strip for zigzag springs. The wire is fed through a CNC spring forming machine that bends, coils, and cuts the spring to precise specifications. Each coil or zigzag must be exactly the same dimension because variations create uneven force distribution. After forming, springs are heat-treated to relieve internal stresses and establish the desired spring rate. A batch of springs is then sample tested on a force measurement machine to verify that the spring provides the specified force at the specified compression. Springs that fall outside tolerance are ejected. Follower production for polymer magazines is typically done by injection molding, often using the same molding machines that produce the magazine body but with different molds. Metal followers are stamped or machined, depending on the design complexity. The anti-tilt features of modern followers require precise dimensional control because the follower must slide freely inside the magazine body while maintaining full contact with the internal guide ribs. Too tight and the follower binds. Too loose and it tilts. The clearance between follower and body wall is typically measured in tenths of a millimeter. Getting it right is the difference between a magazine that feeds and a magazine that jams. Assembly of a complete magazine from its individual components is surprisingly manual in most factories. An assembly worker places the spring into the body, positions the follower on top of the spring, compresses the assembly, and attaches the base plate to retain everything under compression. Some facilities use semi-automated assembly fixtures that hold the magazine body and compress the spring mechanically, but the final base plate attachment and quality check are typically performed by hand. It is one of those manufacturing processes where human dexterity and judgment are still more efficient than full automation. Quality control in magazine manufacturing is relentless because the consequences of a defective magazine are potentially lethal. Every production batch undergoes dimensional inspection, where sample magazines are measured at dozens of critical points using coordinate measuring machines. Feed lip spacing, which is the most critical dimension, is checked with go and no-go gauges. Body width, length, and curvature are verified against engineering drawings. Spring force is tested at multiple compression points. Follower fit and movement are checked manually. And a representative sample from each batch is function tested by loading and feeding through an actual weapon. Magazines that fail any inspection point are scrapped, not reworked. The economics of magazine production reveal why magazines are both remarkably cheap and remarkably precise. A standard 30-round PMAG retails for approximately $12 to $15. Of that, roughly $3 to $4 is material cost, $2 to $3 is manufacturing labor and overhead, $1 to $2 is quality control, and the remainder is margin, distribution, and retail markup. The injection mold for the magazine body cost over $500,000. The progressive dies for the metal components cost similarly. These enormous fixed costs are amortized over millions of units, which is why magazine manufacturing only makes economic sense at very high volumes. Military magazine procurement operates at a scale that dwarfs the civilian market. The United States Department of Defense purchases approximately 4 to 6 million magazines per year across all branches. A single large order might specify 1 million magazines delivered over 12 months, with penalties for late delivery and bonuses for early completion. At this scale, even pennies of cost difference per unit translate to millions of dollars. The competition between magazine manufacturers for military contracts is fierce, and the technical specifications run to hundreds of pages of dimensional requirements, material specifications, environmental testing protocols, and quality control mandates. Surface finishing is the final manufacturing step that gives the magazine its appearance and corrosion protection. Steel magazines are typically phosphate-coated, a chemical conversion process that creates a thin layer of iron phosphate crystals on the steel surface. This coating is then oiled or waxed to fill the porous crystal structure and provide a corrosion barrier. The characteristic matte gray or black finish of military steel magazines is the phosphate coating. Aluminum magazines may be anodized, a process that creates a hard oxide layer on the aluminum surface. Polymer magazines require no surface finish, as the polymer itself provides all necessary protection. One less step, one less cost, one more reason polymer has conquered the market. The environmental footprint of magazine manufacturing is a topic that has received surprisingly little attention. Stamping operations generate significant metal scrap, though most of it is recycled. Injection molding produces polymer waste from sprues and rejected parts, which can be reground and reused to some extent. The chemicals used in phosphate coating and anodizing are hazardous and require careful waste treatment. And the sheer energy consumption of running progressive dies, injection molding machines, spring formers, and heat treatment ovens is substantial. A modern magazine factory's power consumption is comparable to a small industrial park. Looking inside the modern Magpul facility in Cheyenne, Wyoming, which was purpose-built for high-volume polymer magazine production, you see the full scale of the operation. Rows of injection molding machines humming continuously. Robotic arms extracting fresh magazine bodies from molds and placing them on conveyors. Assembly stations where workers, assisted by fixtures and gauges, build complete magazines from bodies, springs, followers, and base plates. And at the end of the line, boxes of finished mags stacked on pallets, ready for shipment to distributors worldwide. It is a long way from Benjamin Tyler Henry's workshop, but the question being answered is exactly the same. How do we keep the gun shooting? Every finished magazine that leaves a factory is a small bet. A bet that the steel was the right alloy, that the polymer was the right formulation, that the spring was wound to the right specification, that the feed lips were formed to the right angle, that every dimension at every step from raw material to packaged product was within tolerance. Because when that magazine is loaded and inserted into a weapon and the trigger is pulled, there is no second chance. It feeds correctly or it does not. The factory's reputation, the soldier's life, the shooter's trust, all of it rides on a box with a spring built by machines and hands and mathematics, one unit at a time, millions of times over. Let's talk about the bottomless magazine. You know the one. The hero stands in the middle of a firefight, firing his pistol continuously for 30 seconds straight without reloading. That is roughly 60 rounds from a weapon that holds 17. He never changes magazines. He never runs dry. He simply fires forever, as if his Beretta 92 is somehow connected to an invisible ammunition pipeline from another dimension. This is the bottomless magazine trope, and it is the single most unrealistic element in action cinema, which, given the competition, is really saying something. The original Commando, released in 1985 and starring Arnold Schwarzenegger, is often cited as the peak of the bottomless magazine phenomenon. In the film's climactic assault sequence, Schwarzenegger fires an M16 belt-fed machine gun from the hip while walking, a weapon that weighs over 23 pounds loaded, for what appears to be continuous minutes. The ammunition belt dangling from the weapon seems to regenerate as fast as it is consumed. To be fair, the M60 is belt-fed and could theoretically fire for extended periods with a sufficiently long belt. But the belt visible on screen holds perhaps 100 rounds, and Schwarzenegger fires approximately 400. Movie math, apparently, operates on different principles than regular math. The John Wick franchise, beginning in 2014, marked a dramatic shift in Hollywood's treatment of magazines. Director Chad Stahelski and star Keanu Reeves, both trained extensively with firearms for the films, made the conscious decision to portray realistic magazine capacities and reload sequences. John Wick counts his rounds. He changes magazines at appropriate intervals. He performs tactical reloads, emergency reloads, and even scavenges magazines for fallen enemies. The reloading sequences are choreographed as carefully as the fight scenes, because in the John Wick universe, the reload is part of the dance. The John Wick approach to magazines has influenced a generation of action filmmakers. Films like Nobody, the Equalizer series, and the later Mission Impossible installments now routinely show characters reloading their weapons at realistic intervals. Audiences, trained by John Wick to expect reloads, have become more attentive to magazine continuity. A hero who fires 40 rounds from a 12-round magazine without reloading is now noticed and criticized by audiences who, a decade earlier, would never have counted. John Wick did not just change action cinema. It taught millions of moviegoers what a magazine change looks like. Video games have arguably done more to educate the public about magazine mechanics than any other medium. First-person shooters like Call of Duty, Battlefield, Counter-Strike, and Escape from Tarkov simulate magazine capacity, reload times, and in some cases, individual round management with remarkable detail. Escape from Tarkov, in particular, models magazines as individual items that must be loaded round by round, can be partially spent and retained, and vary in reliability based on type and condition. For millions of gamers, these simulations are their primary frame of reference for how magazines work. The standard video game reload, with a magazine counter resets to full after a brief reload animation regardless of how many rounds were remaining, has created a widespread misconception about ammunition management. In most games, if you fire one round from a 30-round magazine and reload, you get a fresh 30 rounds. The 29 unfired rounds from the discarded magazine simply vanish. In reality, those 29 rounds would be in the magazine you just dropped. You would need to pick up that magazine and reload it later, or accept the loss. Very few games model this reality. Tarkov and Arma are notable exceptions, and both are valued for their punishing realism. The clip versus magazine debate has become one of the internet's most reliable sources of pedantic outrage. The facts are clear. A magazine feeds ammunition into a weapon's action. A clip loads ammunition into a magazine. They are different things. But in casual conversation, movies, television, and even some military usage, the word clip is used interchangeably with magazine. Gun enthusiasts correct this usage with a fervor that borders on the religious. Internet comment sections erupt in theological fury whenever a journalist writes high-capacity clip. The distinction is technically important. The intensity of the debate is, objectively, out of all proportion to its significance. Television crime dramas have their own relationship with magazine reality, and it is strained at best. The detective who fires 2 rounds from his Glock and then racks the slide, ejecting a perfectly good round onto the ground, is a fixture of primetime television. The SWAT team that breaches a room and immediately discards their magazines for fresh ones after firing 0 rounds is another common absurdity. And the forensic examiner who examines a magazine and declares this holds 15 rounds of 9mm fully loaded, as if that information were revelatory rather than printed on the side of the box. appears with depressing regularity. The extended magazine, particularly the drum and the oversized pistol magazine, has become a visual shorthand in media for "this person means business," or alternatively, "this person is dangerously unhinged." A character who pulls out a pistol with a standard magazine is prepared. A character who pulls out a pistol with a 33-round extended magazine is a maniac. A character with a drum magazine on a rifle is a supervillain or a final boss. The magazine size has become a narrative device, communicating character intent through visual excess. The bigger the magazine, the bigger the threat. It is not accurate, but it is effective storytelling. Anime and manga have developed their own stylized relationship with magazines that is worth a brief detour. Japanese animated series frequently depict magazines with impossible capacities, physically impossible reload sequences, and ammunition types that exist purely in the realm of fantasy. The animated series Black Lagoon features a protagonist who dual-wields modified Beretta 92s with what appear to be standard 15-round magazines, but fires continuously for minutes at a time. Ghost in the Shell depicts magazines for cybernetically enhanced firearms that contain hundreds of micro-caliber rounds in caseless configurations. The visual language of the magazine has been adapted, exaggerated, and reimagined by every culture that consumes firearms media. One of the most persistent magazine myths in popular culture is the sound effect. In movies and television, inserting a magazine into a weapon produces a distinctive, sharp clicking sound, usually enhanced in post-production to sound crisp, authoritative, and somehow aggressive. In reality, inserting a polymer magazine into a polymer receiver makes a dull, unremarkable thud. A metal magazine into a metal receiver produces a modest click. The Hollywood version is louder, sharper, and more satisfying because it has been fully designed to communicate readiness and intent. The real sound is disappointingly practical. Video games have also influenced actual magazine design in a curious feedback loop. The popularity of translucent magazines in tactical shooters led to increased demand for real, translucent magazines. The visual appeal of magazine couplers in games drove real-world sales of Magpul PMAG devices. The obsession with fast reloads in competitive gaming has paralleled the growth of competitive shooting sports that emphasize real-world reload speed. The line between simulation and reality has blurred, with each influencing the other in a continuous cycle of inspiration and adaptation. The phrase "spray and pray," a gaming term for firing an automatic weapon while hoping to hit something, has migrated from virtual worlds into common English. It describes a style of shooting that is enabled by high-capacity magazines and rendered irrelevant by basic marksmanship training. In games, spray and pray is a legitimate, if inelegant, tactic. In reality, it is a waste of ammunition and a confession of incompetence. The phrase's migration from gamepad to vocabulary is a small example of how deeply magazine-fed automatic fire has penetrated popular consciousness. We now have idioms derived from the experience of emptying a virtual magazine. Perhaps the most important cultural impact of the magazine's portrayal in media is the normalization of the object itself. Millions of people who have never touched a real firearm have handled thousands of virtual magazines in video games. They know what a STANAG magazine looks like. They know the shape of a Glock magazine. They know the silhouette of an AK drum. This visual literacy, accumulated through thousands of hours of gaming and movie watching, means that the magazine has become one of the most widely recognized mechanical objects in the world. More people can identify a 30-round magazine than can identify a carburetor, a circuit breaker, or a timing belt. The magazine has achieved a cultural ubiquity that its creators never intended and probably never imagined. Every museum has a backroom, a storage area where the objects too strange, too broken, or too obscure for the main galleries are kept on dusty shelves, waiting for someone curious enough to ask about them. The history of the magazine has such a backroom, and it is filled with designs so unusual, so mechanically eccentric, and so gloriously impractical that they deserve to be seen, if only to remind us that the path from what if to that actually works is littered with fascinating wreckage. The harmonica gun, popular in the 1850s and 1860s, used a flat steel bar with multiple chambers drilled through it, each loaded with powder and ball. The bar slid horizontally through the action, and each chamber was aligned with the barrel in turn. It was, in essence, a horizontal, linear magazine where each round was a self-contained chamber. The jar harmonica pistol could hold up to 10 chambers. In practice, the harmonica was heavy, unwieldy, and prone to gas leakage between the chamber bar and the barrel. But it was conceptually a magazine, multiple rounds stored in a single device and presented sequentially to the firing mechanism. The Japanese Type 11 light machine gun, adopted in 1922, used what might be the most unusual feed system ever fielded by a major military. Instead of a box magazine, drum, or belt, the Type 11 had a hopper on the left side of the receiver that accepted standard 5-round Arisaka rifle stripper clips. The gunner stacked 6 clips into the hopper, and the weapon's action stripped round from the bottom clip, one at a time. When a clip was emptied, it fell out the bottom, and the stack dropped down, presenting the next clip. In theory, this allowed the light machine gun to use the same ammunition and clips as the standard infantry rifle, simplifying logistics enormously. In practice, the Type 11's hopper feed was a nightmare. The system required lubricated cartridges to function because the direct blowback action lacked the primary extraction of a locked breech. An oil pump in the hopper reservoir coated each round with a thin film of lubricant as it fed. This lubricant attracted dirt and sand with the enthusiasm of a magnet in a scrapyard. In the humid jungles of China and Southeast Asia, the Type 11 jammed with distressing regularity. The hopper feed, for all its logistical elegance, was a mechanical disaster. It is remembered today primarily as a cautionary tale about the dangers of prioritizing logistics over reliability. The Gatling gun's original feed systems deserve examination as some of the earliest attempts at high-volume ammunition feeding. Richard Gatling experimented with several feed mechanisms, including a gravity-fed hopper mounted above the breech and a drum magazine called the Bruce feed. The Bruce feed was a vertical drum that sat on top of the Gatling and used gravity plus the rotation of the barrels to feed rounds into the mechanism. It held 400 rounds and weighed nearly 30 pounds loaded. It was, by any measure, an engineering marvel for the 1870s, and it demonstrated that high-volume feeding was possible if you were willing to accept the weight penalty. The Ackles drum, developed in the 1890s as an improved feed for the Gatling gun, was a flat pan magazine that sat on top of the weapon and used a clockwork-driven mechanism to rotate rounds into feeding position. It held 104 rounds and represented one of the earliest examples of a powered feed mechanism. The Ackles drum was adopted by the Royal Navy for shipboard Gatling installations, where the weight of a power drum was irrelevant compared to the advantage of reliable, high-speed feeding in a maritime environment. It was a magazine that required winding like a clock, because in the 1890s, clockwork was the closest thing to a reliable motor that you could mount on a weapon. The saddle drum, used on the DP-28 and its successor, the DPM, is a design we touched on earlier, but deserves more attention for its sheer visual oddity. The pan magazine sits flat on top of the weapon like a dinner plate. It gives the DP-28 a profile that is completely unlike any other machine gun. Low, flat, wide, with a circular disc perched improbably on the receiver. Soviet propaganda photographs of soldiers charging with DP-28s held at the hip, the pan magazine gleaming like a metallic halo, became iconic images of the Great Patriotic War. The weapon looks simultaneously absurd and menacing. It is the combat firearm equivalent of wearing a top hat to a boxing match. The FG-42, the German paratrooper rifle of World War II, used a horizontally mounted box magazine that fed from the left side of the weapon. This unusual orientation was chosen because the FG-42 was designed to be fired from a prone position, and a bottom-fed magazine would have raised the shooter's profile above cover. The left side magazine kept the weapon flat while still using a conventional box magazine feed. The FG-42's magazine held 20 rounds of 7.92 by 57mm Mauser and was one of the few successful implementations of a side-feeding box magazine on a select fire weapon. The design influenced the later M16 machine gun, which also uses a left side feed, albeit from a belt rather than a magazine. The gravity magazine, used on the earliest Gatling guns and some experimental weapons, is the simplest possible feeding mechanism, a hopper or tube mounted above the action, relying purely on gravity to drop rounds into the feeding position. No spring, no follower, no mechanical force, just the weight of the cartridges themselves. The obvious limitation is that the weapon must remain upright for gravity feed to work. Tilt it sideways and the rounds stop falling. Point it upward and the rounds roll backward. Gravity magazines are inherently orientation dependent, which limits the weapon to fixed or stable mountings. You will not be running through a jungle with a gravity-fed weapon. Not successfully, anyway. The Dar machine gun, a French design produced from the 1910s to the 1940s, used a belt feed system with an unusual twist. The belt was stored in a flat pan that rotated on a spindle mounted to the weapon. The belt coiled inside the pan like a clock spring, and as the weapon consumed ammunition, the pan rotated, paying out belt from the inside of the coil. When the pan was empty, it was removed and replaced with a full one. It was a hybrid between a belt feed and a pan magazine, combining elements of both in a characteristically French display of mechanical ingenuity that was simultaneously impressive and unnecessarily complicated. The Becker revolving cannon, used on German aircraft in World War I, fed from a large drum magazine mounted on the side of the receiver. But the Becker was a 20mm autocannon, not a rifle, and its magazine held 12 enormous 20x 70 MMRB shells. Each shell was the size of a man's thumb. The drum was correspondingly massive, weighing over 15 kilograms fully loaded. The Becker's drum was one of the earliest examples of a high-caliber rotary magazine, and it influenced the later Oerlikon cannon series, which became the most widely used anti-aircraft autocannon of World War II. Some magazines have pedigrees that stretch across decades and continents. The Rothsteyr Model 1907, an Austro-Hungarian military pistol, used an internal magazine that was loaded through the top of the action using stripper clips. A semi-automatic pistol with a non-detachable magazine, loaded by clips. This combination of features was a transitional design, bridging the gap between the clip-loaded bolt-action rifle and the magazine-fed semi-automatic pistol. The Rothsteyr's internal magazine held 10 rounds of 8mm Rothsteyr, and the weapon was issued to Austro-Hungarian cavalry units who, one imagines, had very specific opinions about trying to load stripper clips while on horseback. The Mauser C96, the iconic broom-handle pistol, originally used a similar internal magazine loaded by 10-round stripper clips. Later variants accepted detachable box magazines, and during the Chinese warlord era and the Spanish Civil War, numerous aftermarket extended magazines of 20 and 40 rounds were produced by local manufacturers of widely varying quality. Some worked, many did not. The C96 with a long box magazine and a wooden holster stock became a symbol of Chinese revolutionary fighters and Spanish militiamen. A pistol trying very hard to be a carbine, fed by a magazine that was trying very hard to be reliable. The knock volley gun of the 1780s, while not a magazine-fed weapon in any conventional sense, represents an alternative approach to the volume of fire problem that is worth acknowledging. Instead of feeding multiple rounds sequentially through a single barrel, the knock used 7 barrels arranged in a cluster, all fired simultaneously by a single flintlock mechanism. 7 shots, instantly, with no magazine, no feeding mechanism, and no reload between volleys. The recoil was so brutal that it dislocated shoulders. The blast was so enormous that it set ship rigging on fire. It was, in every conceivable sense, a terrible idea. But it was a terrible idea that came from the same fundamental desire that drives all magazine design, the desire for more firepower. The Panker Jackhammer, a prototype fully automatic 12-gauge shotgun developed in the 1980s, used a revolving cylinder magazine that functioned like an oversized revolver chamber. The 10-round cylinder sat behind the barrel and rotated with each shot, presenting a fresh shell to the chamber. The cylinder could be preloaded and swapped as a unit, functioning like a giant detachable revolver speed loader. Only 2 or 3 prototypes were ever made, and the weapon never entered production. But it demonstrated that the revolver concept could be scaled up and applied to shotgun ammunition in a way that was mechanically functional, if somewhat terrifying in its proportions. The Metal Storm system, developed by an Australian company in the late 1990s, eliminated the magazine entirely by stacking multiple projectiles and propellant charges nose to tail inside a single barrel. Each barrel contained multiple rounds separated by propellant charges, all fired electrically in sequence from the muzzle and backward. A single barrel could fire its entire stack at rates exceeding 1 million rounds per minute. A multi-barrel Metal Storm array could fire millions of rounds in a single second. The magazine, in the Metal Storm concept, was the barrel itself. The ammunition was the magazine. The entire distinction between weapon and feeding device collapsed into a single, terrifyingly efficient, disposable tube. These forgotten and unusual designs remind us that innovation is not a straight line. For every successful magazine that achieved mass production and battlefield adoption, dozens of creative alternatives were proposed, prototyped, and abandoned. Gravity feeds, clockwork drums, steep-clip hopper, revolving cylinders, stacked projectile barrels. Each one was someone's best idea, pursued with genuine conviction and considerable engineering talent. That most of them failed does not diminish their value. They expanded the boundaries of what was possible, and in many cases, their failures taught more than their contemporary successes. We have examined every significant magazine type in existence. Tubes, boxes, drums, rotaries, helicals, pans, belts, clips, caskets, and hoppers. We have explored their engineering, their materials, their failures, and their triumphs. Now comes the audacious part. We're going to rank them, not by type, but by individual design. The greatest magazines ever made, evaluated by the criteria that matter: reliability, innovation, historical impact, manufacturing elegance, and sheer longevity. This is subjective, this is opinionated, and this is, frankly, going to annoy a significant number of people. Let's begin. Before we rank, let us establish what makes a magazine great. Reliability is the foundation. A magazine that does not feed consistently has failed its primary mission, regardless of how clever its design. Innovation measures how significantly the design advanced the state of the art. Historical impact considers how the magazine influenced warfare, firearms development, or culture. Manufacturing elegance evaluates how efficiently the design can be produced at scale. And longevity measures how long the design has remained in service or production. A truly great magazine scores highly across all 5 criteria. There are fewer of those than you might think. Starting from the foundation, the AK-47 steel magazine deserves recognition as one of the most robust feeding devices ever mass-produced. It is not the lightest, it is not the most refined, it is not the most innovative, but it is arguably the most reliable magazine ever manufactured in large quantities, functioning in conditions that destroy lesser designs. Hundreds of millions have been produced across dozens of countries. It has been in continuous service since 1949. It functions in Arctic cold, desert heat, tropical humidity, and everything in between. The AK-47 magazine's genius is not in what it does, but in what it refuses to stop doing, no matter the circumstances. The Magpul PMAG, in its various generations, represents the single most commercially successful magazine redesign in firearms history. It took the STANAG concept, identified every weakness, and engineered solutions for all of them. Anti-tilt follower, polymer construction, constant curve geometry, dust cover. The PMAG did not invent anything new. It simply did everything better than what came before. In the 15 years since its introduction, the PMAG has become the de facto standard magazine for the AR-15 platform worldwide. That is not dominance. That is conquest. The PMAG did to the aluminum STANAG magazine what the automobile did to the horse. The Lee Enfield's 10-round detachable magazine, first fielded in the 1890s, deserves a place near the top of any honest ranking for the simple reason that it set the template for every military box magazine that followed. Double stack, detachable, loaded by charger clips or swapped for a fresh magazine. These features, revolutionary in the 1890s, became the universal standard within 50 years. The Lee Enfield magazine was not just good, it was prophetic. It predicted the future of magazine design and got the prediction right by over a century. The Glock pistol magazine, standardized across the entire Glock lineup, represents a masterclass in design simplicity and manufacturing efficiency. A stamped steel body insert, a polymer shell, a flat wire spring, and a polymer follower. That is the entire parts list. The Glock magazine has been produced in quantities exceeding 100 million units. It feeds every variant of 9mm, .40 S&W, .357 SIG, .45 ACP, and 10mm auto that Glock chambers. Its reliability is legendary. Clean, dirty, hot, cold, wet, dry. The Glock magazine simply works. Gaston Glock's genius was not in the pistol. It was in making the pistol and its magazine so simple that failure became almost a logical impossibility. The M1 Garand in-block clip, despite its limitations, ranks highly for historical impact alone. It fed the weapon that armed the force that won the largest war in human history. Over 6 million M1 Garands were produced, and every single round fired through every single one of them was delivered by an 8-round in-block clip. The clip was simple, cheap, and fast. It enabled a rate of fire that outclassed every bolt-action rifle on any opposing battlefield. The ping, the myth, the cultural legacy. The Garand clip transcended its mechanical function to become a symbol. Not many feeding devices achieve iconic status. The Garand clip did. The FNMAG's feed system, and by extension the M240's, earns recognition as the finest belt feed mechanism in the general-purpose machine gun category. Its reliability in sustained fire, across temperature extremes, and in contaminated environments is essentially unmatched. The M240 has been chosen by more than 80 nations not because of political pressure or price, but because its feed system works better than the alternatives. In the world of belt-fed weapons, where feeding failure can mean the loss of a squad's suppressive fire capability, the FNMAG feed mechanism is the gold standard against which all others are measured. The Ruger 1022 rotary magazine holds a special place on this list for demonstrating that not every great magazine design needs to be high capacity or militarily relevant. The 10-round rotary spool, compact, flush-fitting, and supernaturally reliable with a .22 long rifle cartridge, has made the 10-22 one of the most popular rifles in history. Over 60 million rotary magazines produced. Decades of production. A design so refined that competitors have largely stopped trying to improve upon it and simply designed their own versions of the same concept. In its niche, the Ruger rotary magazine is perfect. Actual perfection, not marketing perfection. The FNP90 magazine, with its 50-round horizontal box and 90-degree feed rotation, ranks as the most innovative magazine design of the modern era. Nothing else looks like it. Nothing else works like it. And despite its mechanical complexity, it functions with reliability that approaches conventional box magazines. The P90 magazine is proof that the fundamentals of magazine design had not been fully explored by the late 20th century. There are still entirely new geometries waiting to be discovered, new feeding concepts waiting to be engineered. The P90 magazine is a reminder that the next breakthrough might come from a direction that nobody expects. The M13 disintegrating link, though technically not a magazine, deserves mention for its sheer ubiquity and significance in the belt-fed world. Standardized across NATO, the M13 Link has been produced in the billions. It has fed 7.62 millimeters ammunition through M60S, M240S, Mk48S, and dozens of other weapons across every conflict NATO has participated in since the 1960s. The M13 is to belt-fed weapons what the STANAG magazine is to rifles, a universal standard that enables interoperability across an entire military alliance. Its design is invisible, mundane, and absolutely indispensable. The Winchester Model 1873's tubular magazine earns inclusion for cultural impact that transcends military metrics. It was the magazine that fed the gun that won the West. Whether or not that slogan is historically accurate, the Winchester 73 and its tubular magazine became the defining firearm of the American frontier. Cowboys, lawmen, settlers, and outlaws all carried Winchesters, and a lever-action rifle with its tube full of rounds became an icon of American identity that persists to this day. Henry Repeating Arms, the spiritual successor to Winchester, still produces lever-action rifles with tubular magazines that would be immediately familiar to a frontier marshal from 1880. Ranking magazines is ultimately an exercise in values. If you value raw reliability above all else, the AK-47 magazine sits at the top. If you value innovation, the P90 magazine takes the crown. If you value historical impact, the Lee Enfield magazine or the Garand clip might lead the list. If you value the intersection of all criteria, the Magpul PMAG makes a compelling case for the greatest magazine of the modern era. Reliable, innovative enough to displace the incumbent, historically significant in reshaping the market, efficiently manufactured, and durable enough to establish a new standard. But reasonable people can disagree, and they will. Loudly. On the internet. At length. What this exercise reveals, beyond the rankings themselves, is that greatness in magazine design is not about complexity. The greatest magazines on our list are not the most mechanically sophisticated. They're the ones that most elegantly balance all the competing demands: capacity versus size, reliability versus cost, durability versus weight. The AK magazine is stamped steel and a spring. The PMAG is molded polymer and a spring. The Glock magazine is a shell, a liner, and a spring. The Garand clip is a single piece of stamped steel. Simplicity, executed with precision, is the common thread. The greatest magazines are great because they do not try to be clever. They try to be right. We began this documentary with a simple question: how do we keep the gun shooting? We have spent 5 hours answering it. We have traveled from the hand-cranked Gatling feeds of the 1860s to the electromagnetic magazine concepts of the 2020s. From stamped steel to injection-molded polymer. From 7-round tubes to 100-round drums. From the mud of the Western Front to the sand of Afghanistan. From the factory floor to the internet forum. The full story of the gun magazine, told with the depth and detail it deserves. And now, at the end, it is worth asking a different question. Not how the magazine works, but what the magazine means. The magazine is, at its most fundamental, an amplifier. It amplifies a human being's ability to project force. A person with a single-shot weapon can fire once per loading cycle. A person with a magazine-fed weapon can fire 30 times, 50 times, 100 times before pausing. The magazine does not change the nature of the force. It changes the scale. And in changing the scale, it changes everything. The tactical calculus, the strategic equation, the relationship between attacker and defender, between individual and group, between the armed and the unarmed. This amplification has been used for purposes that span the full moral spectrum of human activity. Magazines have fed the weapons that liberated concentration camps and the weapons that guarded them. They have enabled police officers to protect communities and enabled criminals to terrorize them. They have fed the rifles of soldiers defending their homelands and the rifles of soldiers invading someone else's. The magazine is morally neutral. It is a spring in a box. It does not choose its owner or its target. The choices belong entirely to the human being who loads it. The history of the magazine is, in a very real sense, the history of the industrialization of warfare. Before the magazine, combat was personal. One shot, one reload, one shot. The pace of killing was limited by the pace of the individual human loading a weapon. The magazine removed that limitation. It turned combat from a series of individual actions into a continuous flow of fire. It transformed the battlefield from a place where individuals fought into a place where systems fought. The magazine was not the only technology that enabled this transformation, but without it, the transformation could not have occurred. Consider the arithmetic. At Waterloo in 1815, a British infantryman with a Brown Bess musket could fire 3 rounds per minute. At the Somme in 1916, a machine gunner with a belt-fed Vickers could fire 500 rounds per minute. At Fallujah in 2004, a squad of Marines with magazine-fed M4S and a belt-fed M249 could collectively deliver over 3,000 rounds per minute. In 190 years, the rate of fire per combatant increased by a factor of roughly 1,000. The magazine, in its various forms, was the technology that made that 1,000-fold increase possible. The democratization of firepower is perhaps the magazine's most profound legacy. In the age of the single-shot musket, a well-drilled army could fire faster than a mob. Training and discipline mattered enormously because the loading sequence was complex and could only be performed efficiently under battlefield stress by soldiers who had practiced it thousands of times. The magazine reduced the skill required for sustained fire. Load the magazine. Insert it. Pull the trigger. The mechanical complexity moved from the soldier's hands to the magazine's interior. The magazine, in effect, democratized the ability to sustain fire. And in doing so, it changed who could fight and how they fought. This democratization has had consequences that the magazine's inventors never anticipated and could not have prevented. The global proliferation of magazine-fed weapons, particularly the AK-47 and its variants, has placed sustained fire capability in the hands of every army, militia, insurgency, and criminal organization on Earth. The 30-round magazine is as common in sub-Saharan Africa as it is in NATO arsenals. It is as available in a Kandahar market as it is in an American gun store. The magazine's simplicity and durability, the very qualities that make it an engineering triumph, also make it virtually impossible to control. A good magazine lasts forever, and forever is a long time for an object that amplifies violence. Yet the magazine has also enabled the defense of the defenseless. It has allowed outnumbered forces to hold positions against overwhelming odds. It has given individual citizens the means to defend themselves and their families. It has equipped the Ukrainian Territorial Defense Volunteer and the Swiss militia member and the Israeli reservist with a sustained fire capability that their security depends on. The same 30-round magazine that enables an aggressor also enables a defender. The technology is symmetrical. The morality is not. The engineering legacy of the magazine extends far beyond firearms. The principles of spring-loaded feeding, sequential presentation, and automatic indexing that were developed for ammunition magazines have been applied to dozens of other technologies. Nail guns use magazine feeds derived directly from firearms magazine concepts. Surgical stapler cartridges operate on principles identical to a box magazine. Automated assembly machines use feeding mechanisms that trace their lineage to the belt feeds of World War I machine guns. The magazine's engineering DNA is embedded in technologies that most people would never associate with firearms. Let us take a moment to appreciate the sheer scope of what we have covered. 20 chapters, hundreds of scenes, thousands of years of history compressed into a few hours. We have examined tubes, boxes, drums, rotary spools, helical spirals, pans, saddle drums, belts, clips, caskets, coffin magazines, quad stacks, gravity hoppers, harmonica bars, and stacked projectile barrels. We have discussed steel, aluminum, polymer, bakelite, titanium, and carbon fiber. We have met James Paris Lee, Benjamin Tyler Henry, Ferdinand Mamlicher, Paul Mauser, John Garand, Mikhail Kalashnikov, Gaston Glock, and the engineers at Magpul. We have visited battlefields from Omdurman to Stalingrad to Fallujah. And through all of it, one thread has remained constant: the relentless human drive to solve the problem of sustained fire. Every magazine design we have examined is an answer to the same question that a Civil War cavalryman asked when his Spencer ran dry, that a World War I machine gunner asked when his belt ran out, that a modern Marine asks when his PMAG goes to bolt lock. How do I get more rounds into this weapon, faster, more reliably, with less weight and less complexity? The question never changes. The answers keep getting better, but the question never changes. The magazine will continue to evolve. New materials will make it lighter. New manufacturing techniques will make it cheaper. New electronics will make it smarter. New ammunition will change its shape. But as long as humans use kinetic projectile weapons, and that will be for a very long time yet, the fundamental concept will endure: a container that stores multiple rounds and presents them, one at a time, to the weapon's action for chambering. James Paris Lee would recognize a modern PMAG. He would understand its purpose instantly, and he would, I think, be quietly proud of how far his simple idea has traveled. There's a poet's observation that every tool is a frozen intention. The hammer intends to strike. The saw intends to cut. The magazine intends to keep the weapon shooting. That intention, frozen in steel and polymer and spring wire, has been expressed in every conceivable geometry, every available material, and every manufacturing process that human ingenuity could devise. The magazine is a small object with an enormous intention, and that intention, for better and for worse, has shaped the world we live in. Every firearm on Earth, right now, at this moment, either has a magazine inserted or has one nearby waiting to be loaded. There are, by conservative estimate, over 1 billion magazines in existence worldwide. If you line them up end to end, they would circle the equator several times. They are in military armories, police stations, gun safes, nightstands, chest rigs, factory warehouses, museum cases, and evidence lockers. They are in hands you would trust and hands you would not. They are being loaded, fired, emptied, reloaded, maintained, modified, collected, discarded, and manufactured right now as you hear these words. The story of the gun magazine is the story of a species that excels at solving mechanical problems and struggles with the moral implications of the solutions. We build a device that keeps weapons shooting and then spent 160 years debating whether keeping weapons shooting is a good thing or a bad thing. The debate will continue. The magazine does not care about the debate. It is a spring in a box. It has no opinions. It has no conscience. It has only a function. And it performs that function with a mechanical indifference that is both its greatest virtue and its most unsettling quality. So the next time you pick up a magazine, any magazine, whether it is a 7-round 1911 magazine that your grandfather carried, a 30-round PMAG that you bought last week, or a 100-year-old Luger trommel in a museum case, take a moment. Feel its weight. Look at its geometry. Think about the spring coiled inside, waiting. Think about the follower, poised to push upward the moment a round is stripped away. Think about the feed lips, angled to present the next round with the precision of a mechanical ritual performed billions of times across a century and a half of human history. Because that magazine, that simple, humble, taken-for-granted box with a spring, is one of the most consequential objects in the history of human technology. It is an object that changed the nature of warfare, reshaped the balance of power between individuals and between nations, generated billion-dollar industries and centuries of legislation, inspired both engineering brilliance and moral anguish, and inserted itself so deeply into human culture that we have idioms, myths, and art forms built around it. It is a box with a spring, and it changed the world. Thank you for watching.